Welcome to Game Development with UDK. I'm John P. Doran, and I've been working with Unreal Engine 3 for the past 5 years, working on projects like Unreal Demolition to projects like Star Wars 1313. I'm also the author of 3 other books having to do with using UDK for game development. Over the course of the next 2 hours or so, we're going to be going over the basics to get you started with the Unreal Development Kit, UDK for short, completing a sample project at the same time. But before we get started with building the game, let's take a look at what it is we're actually going to make. And as you can see here, we've got a main menu. And when we press the Enter key, as you can see here, we have a third-person platformer game with a very simple level that we've created using geometry and some additional model. We also have collectibles that we created using Kismet, the Unreal Engine's visual scripting language. In addition, we will also use Kismet to have checkpoints, which will allow us to respawn close to where we've died previously. We're also using a custom camera system that we've created using UnrealScript, Unreal Engine's programming language. Lastly, we'll talk about how to customize our UDK game to replace the default game shown when we start the game, including our own main menu, loading screen, and splash screens. And now that we know what it is that we're going to be building, let's get started with the first step needed to build our game, installing the Unreal Development. If you already have UDK installed, feel free to skip this video. But for those of you that haven't, let's get started. Now before we get started making anything with UDK, we first need to get it installed to our computers. So the first thing I want you to do is open up your web browser of choice. Once it's up, I want you to go to the UDK website at www.udk.com. Once there, you should see a Download UDK button right here on the right-hand side, where we can find the latest installer for UDK. This brings us to the installer page. Epic Games, the makers of UDK, releases updates for UDK on a fairly regular basis. For our purposes, I want to mention that we're going to be using the latest version of UDK, which is the July 2013 version. Now I'm going to click that to download it. And you'll notice that it's a 1.9 gigabyte file, so it may take a while. So I'm going to pause the video once I hit Save Files, and then when it finishes, we'll come right back. And with that, our download is complete. Now, if we go into our Downloads folder, we should see our executable that we then need to run. Now, if you do happen to get a prompt asking you to install Microsoft.NET, please install that as well. However, do note that it will ask you to restart, so be sure to save your work and other applications before starting it. If you get a security warning asking if you want to run the file, let's click Run. Now, the first thing you'll see pop up is an end user license agreement. Now, please read this carefully to make sure you know what you're getting into, and then afterwards, click on the I accept button. Once you do accept, we do want to select to use this UT sample game project, as we're going to be using the Unreal Tournament code as a basis for which we can extend to create our final project. So after this, I want you to hit Next. And then we'll ask for the installation location or the install folder for where we want to put UDK. Now, this is a good idea to remember what folder this is, as I'll be referring to your UDK install folder a number of times over the course of this video. After this, should hit install, and the installation should take a few minutes to complete. Once it finishes doing the main install, it'll ask you if you want to install anything extra. We're not going to be covering any of it in the course of this video series, but you can install it if you want to. I'm just going to hit next. And just like that, installation is now complete. Now, I'd love to jump straight into launching the UDK editor and start working on a project, but I think it's important to go over what it is that we've actually installed and help give you some familiarity with the basic structure that UDK has. So instead of launching, I'm going to return to desktop, hit finished, and that's what we're going to do next. Epic Games provides us with a number of example maps and files which are very much worth exploring before setting off on the development of our own game. So we're going to go into the location of our UDK install folder, and we're going to talk about what it is these directories are. Now, the binaries folder here holds a number of different executable files, including the main UDK program, which is located inside of the Win32 or Win64 folders. This also includes a lot of tools that can be used for artists and animators. Besides the UDK executables, we probably won't be touching any of the stuff inside of here, aside from the Unreal front end, but I'll briefly cover what these other folders hold. Now, Actor X has plugins inside of it to export models from 3ds Max or Maya. The FaceFX plugins folder are tools for character facial animations. GFX is all about the tools being used for Flash to integrate scaleform into your game for heads-up displays or other things. Install data are the files that are used during UDK's installation. The iPhone and Mac folders here contain packager programs used to export your game to be used for the iPhone or the Mac, respectively. The SpeedTree Modeler folder is the location of SpeedTree, which is a program that you can use to create nice-looking trees and vegetation for your game levels. And then finally, here the Win32 and the Win64 folders contain the 32 and 64-bit versions of UDK and all the libraries needed to run it. This is also where the executable will run when we open UDK. Now, the development folder here holds all the UnrealScript as well as Flash files for different classes that are used for the game. Now, we'll be using this folder when we create code of our own later on in the project. For those of you who are comfortable with coding, you should feel free to read and extend things that were already created, but it is incredibly important for me to mention that we should never alter any of Epic's code. Next, the engine folder is where all our engine files are located, holding resources and configuration files. We won't be using it, as you should not change any of the content in this directory, as that's what the UDK game folder is for. Now, UDK game will have a host of other directories which may be useful for someone to use. The autosaves folder probably doesn't exist for you, as we haven't used UDK yet, but when you're working on levels later, this folder will be created in order to have backups of files that you're working on. Now, this isn't a replacement for you saving yourself, but in case UDK unexpectedly shuts down, you may have a chance to recover most of the work that you did. The build folder here contains assets that are required for publishing on different platforms. The config folder contains all the INI files which we can use to change how the game itself functions. Content is a folder where all the assets that we create for our levels will go into. Now, the file organization doesn't matter too terribly much as long as it makes sense to you. Now, as long as it's inside of here, UDK will be able to find it. If you go into the UDK game folder and then content, maps, you'll see some levels already inside of here. Now, you won't see these because they're what we're creating over the course of the project, but you'll see other examples. You'll see mobile project. You'll see the showcases. And you'll also see a couple of different levels that were created from Unreal Tournament 3. This is here where you'll be interested in seeing how the pros make levels and learn from them yourself. Now, the Flash folder here, for those of you that are interested in integrating Scaleform into your projects, this would be a good resource that have example files just for that purpose. You'll need to have Flash in order to open the files. The localization folder here contains files for converting your game into other languages. Log. UDK keeps a record of whatever it is that you do when you run it, so if an error occurs, you'll be able to use that to see what's going on. Now, we'll be using this later on when we dive into UnrealScript later. The Movies folder. Any cutscenes that you'd like to use will be placed in there. We'll also learn how to replace these assets with our own later on in Section 8. Project Template. This is a feature that hasn't been implemented yet and isn't mentioned in any official documentation about UDK, so I'm going to skip over it. The Script folder contains all of the generated source code after it's been compiled. Now, this isn't very much use for us, as this code will be masked from other people being able to read it. The Splash folder contains images that will show up when the game starts, and it also has links for the UDN, as well as Epic's forums. Now, we'll be replacing these images later on in Section 8. Now that we have a firm foundation of what UDK is and what it contains, but we haven't done anything with it yet. Let's change that as we begin the next section, building our first level. In this video, we're going to learn how to open up UDK and take the first steps towards building our third-person platformer game by setting up the player's jumping ability. Here on Windows 7, I can go to the Start menu and select Start, All Programs, Unreal Development Kit, select my version, and then UDK Editor. For those of you who are running Windows 8, you can simply open up the Start menu by pressing the Window key and then selecting the new icon that shows up for the Unreal Development Kit, so UDK Editor. So now when we have the program opened up, we should be able to have our default level here, which we can play by either going to Play in Editor or press the F8 key. Now at this point, if we're walking around using the WASD keys, we can jump by pressing the spacebar. But you'll notice that when we press the jump with the spacebar, that we don't go very high. Thankfully, there are a number of ways that we can fix that. So let's see how we can do this using the console window first. So you can open up a console window inside of UDK by either pressing the Tab or by pressing the tilde key. Now, one of the actions that exist inside of the console window is set jump Z, which will set how high the player can jump. So for right now, let's type in set jump Z 750, and you'll notice that now if I press the spacebar, I go much higher. Now, we don't want to have our players to type that in every single time that they play the game. What we want to do is, whenever our player gets spawned, we want to jump this high without having our player use the console window. Thankfully, we can use Kismet to do that for us automatically. Kismet is a visual scripting language that allows us to develop prototypes or even create entire games without writing a single line of code. And as Unreal Engine 4 isn't using UnrealScript, it's very important that we cover Kismet in this course. However, as of the time of this recording, we don't know when the general public can use UE4, so we'll be talking about UnrealScript as well. Now, we'll be talking about Kismet far more in later sections, and it'll be explained in far more detail, but for right now, I just want to show you a very simple example. So the first thing we need to do is we need to open up the Kismet interface by clicking on this K icon at the type of the UDK interface on the main toolbar. From there, we first need to create a player spawned event, which will be called whenever the player appears on the map. So inside Kismet, we can right-click anywhere inside of this large area in the upper portion of the interface. From here, we want to create a player spawned event by choosing New Event, Player, Player Spawned, and then left-click. Now, once that's done, we want to left-click on the player spawned event sequence object to have the properties window show up here. Now left-click on the sequence event section right here, and we want to change the max trigger count from 1 to 0. Now, this value shows how many times this event can be called. As we want the player to respawn as many times as they want, we use 0 to represent an infinite number of times. So to move around Kismet, we can hold down the left mouse button and drag around. We can move objects by holding Control and then dragging them around. We can also zoom in and out by using the mouse wheel. Now, we want to right-click and create a console command action by right-clicking and then selecting New Action, MISC, and then Console Command from this menu. Now, just the same as ours, we want to open up the properties, and you'll see a section called Commands. Now, inside Command 0, I want to put in the value set jump Z 750. Next, I want to connect a player variable to the target because I want my player to call set jump Z. So to do that, I need to right-click and select New Variable, Player, Player. Then from there, I can click and hold this target to go to all players. I then need to connect the out from the player spawned event to the in of the console command action, and then release. Now if you ever want to delete a connection, I can hold Alt and click to remove a connector. If I want to move this, I can use Control once again and move it. Now, let's play our game again. I'm going to close out of here and select Play once more, and we play the game again. And awesome! Our player can now jump into the air. Now for those of you who are interested in seeing all the various console commands that there exists, the Unreal Developers Network, UDN for short, has all the options available at this address right here. Now for those of you who are also interested in seeing some of the technical details of Kismet, UDN also has a very nice guide on working for it here. And with that, we now have a jumping character and a quick intro to Kismet. This will be quite useful to us later as we move on to building more and more complex things in the future. Next, now that we have our player able to jump, let's start building an area for the character to inhabit. In this video, we're going to be setting up the foundation for our level by first creating a platform, our floor, and the ceiling. Now right now in our level, we only have a very small world with a box in the middle of it. Now that was fine for what we did previously, but now we're actually going to be building our level for our platformer game. First things first, we're going to need to set some properties. Now, inside of UDK, there's a property called KillZ, which will automatically kill your player whenever his collider hits a certain number on the Z axis. If you hit this top right button to restore viewports, you'll actually see this red line here, which is actually the position of where the kill Z is. So if the player actually hit that position, then they'll automatically die. Now we don't want that to be the case, so we're going to want to change this. To do that, we're going to need to go into the World Properties menu by selecting View and then World Properties. Now as you can see here, there are a lot of different properties with a lot of different things inside of it. To easily find this variable, we can make use of the search bar up here at the top. So I'm just going to type in the word kill, and you'll see right there there's that kill Z value, which is currently set to 0. So I'm going to set it now to a -64, and you'll see that that value has now changed. Alright, let's say goodbye to the default floor and box because we won't be needing them anymore. So right here, I'm going to click on the Maximize Viewport button to bring us back to this larger view. And then I'm going to delete these two objects by simply left-clicking on them and then hitting the Delete key. We'll also want to delete this player start right here by also pressing the Delete key because we'll be creating our own later. Then we'll exit out of the single viewport once again by hitting the Restore Viewport button on the top right. And now you'll see that we have 4 different viewports showing the side, front, top, and perspective viewports of our level. And this will be quite useful for us to have when we're starting to build out different levels. Once that's done, you'll notice this red cube in the center of the building here. Now, this is known as the builder brush. The builder brush isn't actually seen when we play the game, but it's a way for us to see something before we use it to create the CSG, or constructive solid geometry, of our level. Now you'll notice on the left there are a number of different kinds of brushes that we can actually create to create our geometry. Like here's a cylinder, here's a staircase, here's a sphere. Now if we right click on any of these, we'll bring up a properties menu for us to type in whatever we want. And that will help us to describe how big our world actually is going to be. Now in general, 16 UDK units is approximately 1 foot. So with that in mind, I'm going to right click on the cube window to bring up this brush builder. And in the X, Y, and Z parameters, I want to type in 512, 512, and then 16 or 32 right here. And then I want you to hit the build button. You'll notice that this here changes to the shape that we've done. Now I'm going to hit the X to cancel out of here. Now generally when I want to block out an area, I always work with large blocks to get an overview of the play in my level and refine it later. So right now I'm using 32 for the floor, but traditionally I would only be using 16. Once we have this set, we can actually add this brush to the stage by clicking on the Add button or by hitting Control A on your keyboard. And now you'll see on this perspective view here that we now have our first BSP or binary space partition brush created. Now that we have one wall created, we don't really need to use the builder brush anymore, so I'm going to press the B key to remove it, as I'll be using geometry mode to build all the other brushes. Now you'll notice that what's left is this blue brush right here. Now the blue brush stands for additive geometry and is the brush that we've just actually created. There are other kinds of geometry as well, and we'll be using one of them, the subtractive, later on in this section. One of the great things that UDK gives us access to, especially for building areas very quickly, is the idea of a grid lock, which can help us snap into place pieces that we want to build. With that in mind, first let's check if our grid lock is enabled, seeing if this section right here is toggled or not. If it is, let's set this number to 64 by either clicking on this drop-down menu or by pressing the right bracket symbol twice. Now the first thing that we want to do is we want to create a copy of this brush to act as our ceiling. To do that, I'm going to move here to the side viewport and I will now select this brush. Upon selecting it, I can hold down the Alt key and then drag up from this blue symbol in order to create a new brush. Now if I want to move around in this camera, I can hold down the left mouse button and then drag it however I want. And I can zoom in and out by using the mouse wheel. So for this instance here, you'll see that we've now created a ceiling. Now we can see this brush in all the different viewports, except we can't see it actually drawn in perspective, because it will only show what's already been built. So to see changes that we've made, we'll have to build geometry to see those changes. To do that, we can go into Build, and then Geometry for current level. You'll get some errors, but we can just hit Close, and you'll notice that now we should be able to see something. To move around in the perspective viewport, I can simply right-click and then drag to move around the character like a view in an FPS game, and I can use the WASD keys to move around. So with that in mind, you'll see that we now have our floor and our ceiling. Now finally, let's add a place for our character to spawn. So I'm going to right click on the floor here, and then I'm going to select Add Actor, and then Add Player Start. And then you'll see here that there's an icon with a little X. I'll move up here. You can press the home key to zoom right in on the actual object. But what you see here, it says bad size. To fix this, we can simply just raise this up until it no longer shows. We can then press the end key to bring it on down. And with that, we now have a floor and a ceiling in our level via creating a brush and duplicating it. And we can actually see what it looks like in the game by going into Play in Editor. In the next video, I'll be talking about how we can use geometry mode in order to block out an area very quickly. We now have a platform and a ceiling, but we have no walls for our area or anywhere to go from here. So let's solve that issue now. First things first, you'll notice that from this object right here, that these lines don't exactly line up to the grid that we've already created. So what I'm going to do is I can select both of these objects by holding down Control and clicking on them. And a neat little trick is I can actually right click on any of these vertices and will snap to fitting on the grid. Now, from the top viewport, what I'm going to do is I'm going to create another copy of this top object here by again holding down Alt button and then dragging in the direction that we want to move it to. Now, we don't want our wall to be this thick, so what I'm going to do is I'm going to use geometry mode in order to build out this area. So in order to enter geometry mode, I can click on this button right here, or press Shift 2. Once I'm in geometry mode, you'll notice that the vertices here of the object changed. Now, the nice thing about geometry mode is that we can modify these vertices to create whatever kind of brush we want to really easily. And by staying on the grid, it'll be super easy for us to block an area out. So what I'm going to do now is I'm going to press Control and Alt at the same time and click and drag to create this red box. This is called a marquee selection window. And now I am going to do this on this section right here. And I can use this to drag and drop an object to fit what kind of vertices I do. So if I drag them here, you'll see that my brush is now being adjusted to fit this particular line. And then if I drag the bottom and put it down, again, if I deselect it, just left click to select it again, then Control Alt, click and drag, and highlight whatever vertices I want to change, and then drag it down. And now, if I go to Build, Geometry for Current Level, I'll close this, and you'll notice that we now have a wall. To make this wall the same size as the others, I'm going to first hit the left bracket key to change the grid size to be 32, and then select this object and do a marquee selection once again. Click here and then drag it over. I'll exit by left clicking. Now we can just simply select the object again by left clicking and then hold down the Alt key and then drag it out. Let go. And there we go. Now we've created a copy of this previous wall. And I'll build the geometry once again. Close, and you'll see that we now have two walls. So for the other two sides of the room, I could simply copy the two ones that I've already created and modify the vertices using the geometry tools, or I could just take these walls and rotate them. And since we haven't done it before, I'm going to show you how to do it with rotation. So first things first, I need to duplicate this brush. So to do that, I'm going to hold down Control, select the other object, then holding Alt, I'm going to left click here and drag, and there you'll see that we now have 2 more additional brushes. Now, these arrows right here are what we refer to as the translation widget. What the translation widget allows us to do is it allows us to move an object within a particular axis. So here for this green line here, this is the y-axis, and the blue line is our z-axis, and the red line is our x-axis. How do I know which one's which? You'll see here in the perspective viewport, when I move, it shows which axis is which. UDK, actually, the z-axis is our vertical one. So from the front, if I move here, it moves up. And then from the top, if I move up, it really is moving forwards or backwards, depending on where the camera is. However, that's not the only kind of modification that we can do with these widgets, with this gizmo. There are actually 3 other additional modes that we can go into. And you'll see here at this top bar, you'll see that there's this blue line around this translation mode. And that's because that's what this gizmo is currently set to. But I can also set it to rotation mode, which shows up here as I can actually rotate my objects. So if I rotate this here by 90 degrees, you'll see that now it's been moved. In addition, there's also a scaling mode. Here is a uniform scaling, which will scale everything in the same direction, and a non-uniform scaling, which will allow me to move something only within a particular axis. Instead of clicking the buttons up here in order to toggle between the different modes, I can actually also just hit the spacebar, and that'll toggle through all of them. So I'm going to go back to translation mode, and then I'm going to move the object from the top to fit the rest of this room. It's important to note that we actually won't see any of these changes that we've made until we build everything inside of our level. So I'm going to do that next after I close my geometry tools. So I'm going to go to Build and then Build All so that the lighting and everything is all set. If you see this pop-up come up, click on Allow Access. And then you should see this all finished. So when we close and we play the game, you'll notice that we're in pretty much complete blackness. And that's because all of our walls are enclosed. So in order to fix that, I'll close out by hitting Escape. To fix that, let's add a light to this level. So holding down the right mouse button, I'm going to use the WASD keys to move into our actual level. And then I am going to place a light by holding down the L key and then clicking on the ground. If I don't remember this hotkey, I'm going to delete this. I can also right click and select Add Actor, Add Light Point. I'll move this up real quick using the Transform tool. And then, because I've changed the lighting in my level, I also need to build lighting before I'll see it. So I'm going to build lighting real quick, hit OK. And once it finishes, when we play the game, we should now have a room with a light. And so we now have a room, but our game won't be built on just rooms alone. So let's go one step further and extend our world to multiple areas, which is what we'll be doing in the next video. In this video, we'll expand on what we've learned in the previous video and build a second room and a pathway between them. So at this current point in the level, we only have a single room. As we're going to be building a platformer, we want to have additional space and actual platforms to walk around in. Let's do that now by first showing just how simple it is to create an additional room. So the first thing that we're going to do is we're going to create a copy of the room that we already have. So to do that, I'm just going to simply go back into geometry mode. I'm going to move this over, and then I'm going to do a marquee selection from the top here of the room that we've just made. So again, I'm going to hold Control and Alt, let go, and we've brought to the selection window. So holding down the Alt key and dragging, there we go. We now have two different rooms. If for some reason the translation widget isn't in a good spot for you, you can actually right-click on any of these vertices and it'll move there as well. So you'll see here, we now have these two rooms, but I want to have some space between them. I'm just going to drag this over some more, and then we are going to actually create a floor between this. So to do that, quite simply, I just need to select the floor from one of my other rooms, and I'm going to duplicate that. So I'm going to hold down the Alt key and drag it over. Notice that I've made this area larger than the other room, so I can simply just do marquee selections on both of these. If you see this come up, this is in local space. So to change this so that it's facing in world space, I can hit the tilde key, which is right by the 1 on a US keyboard. So I'm going to hit tilde, and you'll see that it now is in the correct position. So I'm going to drag this over so that it fills in the room. I'm going to drag this over so that it fills in the room. And then finally, I'm going to grab the top and bring it down some. I don't want the floor to be as big as my other. Now, just give you a visual of what's going on, I'm going to go to Build, Geometry for Current Level, hit a Close, and now you'll see that I have these two rooms. These two rooms, this one still doesn't have any lighting in it, but we'll fix that in a little bit, and we have these floors between them. And this is great and all, but there's still no way to get between the rooms. Thankfully, we can use a different kind of brush in order to help us do that. The subtractive brush. The subtractive brush will cut away at stuff that we've already created before with these blue additive brushes. So in order to create that, I'm going to do the same idea as what I did previously. I'm going to grab one of these walls. I'm going to create a copy, again by holding Alt. I'm going to adjust the size of it by dragging on these vertices. If you ever drag something along like this, you can just simply select it again and move it back. Select the other side, move it over. Now if you look here from the other viewports, you'll notice that it's very, very tall. We don't want that, so I'm just going to select the top again and bring it down. And I'm going to rise it up some because we don't want to cut away at our actual floor. Now, I'm going to move this back into where the door would be previously, and then I need to make this subtractive. So in order to do that, I'm going to press F4, and under this brush section, there's a CSG operator. This is our CSG operation. Right now it's doing additive. I'm going to instead select subtract, and you'll see that it changes into this yellow color. Now I'm going to move over here, and when I finally build my map, close, and we should see the door between. Now another way to create a subtractive brush is by simply using the builder brush, which you again remember here, which I can toggle by pressing B. Instead of pressing here for additive, you could also click here to create a subtractive brush. Alternatively, you can also use Control S. I'll hide the builder brush again by pressing B. Finally, I'm going to create a copy of this door to use for the other side. So I'm simply just going to left click on it till I get there. I can zoom in again using the mouse wheel. I select it, I hold down Option, I drag it over, and I will build again, build geometry. Close on out, and it should be there. Now, if this is not the case and you just see a solid wall, the order in which the brushes are placed is probably off. Now, placing a subtractive brush and then an additive brush will not have the same effect as placing an additive and then a subtractive. If you subtract from empty space and then add on top of that, the subtractive brush is essentially ignored as you can't subtract from nothing. And the opposite holds true. If you place those same brushes in the opposite order, you're adding to the empty space and then subtracting from the addition, carving space out of it. Now, in case you want to change which one of these is first or in front, you can simply select the shape, right-click on anywhere aside from the vertices, select Order, and to First, and that will bring it up to the top. Finally, let's go and play the game by selecting Play in Editor. Now, at this point, you have all the information that you need in order to build out whatever kind of area you like using these simple shapes. Next, I'll be going over how to add some wow factor to this area by adding in some materials and some static meshes. Now, for those of you who are interested in learning more about BSP, you can check out this page here on the UDN, the Unreal Developers Network, talking about how to use BSP brushes and talking about the different kinds of brushes that there are. In this video, we're going to learn how to add in materials and static meshes to our levels to add a bit of polish as well as create a more believable environment. So now that we actually have an area to play in, let's add some features to actually make it look nice. To do this, the first thing that we're going to do is we're going to replace these checkerboard pattern walls with something more realistic, making use of materials and the content browser. Thankfully, adding materials onto brushes in UDK is actually quite simple. First of all, we need to open up the content window by either clicking on this button here or by pressing Ctrl, Shift, and F. Now, once the content browser comes up, let's find a nice material for our floor. So to find something, we can either go through these packages ourselves looking for different things, or we can also use this search bar here at the top. Since we're looking for materials, I'm going to first check off materials, and then you'll see here we've already limited our scope. Next thing I'm going to do is I'm going to type in the word floor here. So anything that has the word floor in it is going to show up. Now this is only within the folders mobile and all the folders that it contains. But if I go to UDK game, you'll see that there's quite a few more. Looking around, I think this is going to be a good material to use. So I'm going to left click in order to select it. And once I do that, I can then apply it to my floor by dragging and dropping it on top of the surface. Alternatively, you can actually select in the floor, right-click, and select Apply Material. And then whatever you have selected inside the content browser will show up. Now, a quick way to do it, once you have something selected, you close the content browser. So now I can right-click and then select Surfaces and then Adjacent Floors, and you'll notice that all the floors are now highlighted. So now I can right-click and select Apply Material, and now you'll see that it shows up. As you may have noticed already, we can also do the same things with the walls as well. But if we do that, we're going to miss out some other additional surfaces like on the ceiling. So in order to do that, I'm going to just left click to select one of these walls, and then I'm going to right click, select surfaces, and then select matching texture. And now everything that has that texture now is selected. So now I'm just going to find what kind of material that I want to use for it. So we need to find a nice wall to use. So I'm inside here, I'm going to go and I'm going to write wall. And I think this one here will do nicely, this block wall 7. So I'm going to right click, then select apply material. And there we go, we now see it. But looking at it here, this material seems to be quite small. It's quite easy to notice the repetition inside of it. So what I'm going to do is I'm going to modify the surface's properties to make it larger. I can do that by going into View and then selecting Surface Properties. And it's going to bring up a menu which will allow us to pan, rotate, scale, or change the alignment of the textures that we're currently working with. Once there, I'm just going to go to the simple scaling option and select 2.0 so that I will double the size of my texture, and I'll hit apply. And there we go. Already it's looking a lot better. Now there's a lot of other features in the menu, and it'll be really nice for those wanting to tweak those values to make the best looking environment possible. Now, another thing we may want to do is add some additional details to our levels. There's a lot of options that we have here, but I think what I'm going to do right now is I'm going to add a staircase somewhere in the middle over here to make it so that we can go to a higher level where we can have our additional platforming sections in our game. So to do that, I'm going to add a static mesh to the level. So from here, in order to do that, we do the same thing that we did for the walls. We go into the content browser, and instead of looking at materials, we're instead going to be looking at static meshes. Now I'm going to remove the wall text, and I want to add some stairs. So for that, I'm going to go type in the word stairs. And here I see SM Stairs SID01 looks perfectly fine. So again, just like working with the materials, I select it, then I can close, and then all I need to do is right click, select add actor, and first we need to load the static mesh. This may not appear on your screen depending on what's loaded. And then all I need to do is right click once more, and I get this add static mesh option. So I'm going to left click on that, and now we've placed these stairs you'll see here. Now I'm going to move it over just like we've done previously with our other stuff. And because I want it to be in front this way, I'm going to place it over here, and I'm going to hit space in order to go back to rotation mode. Click on this axis to move it around 90 degrees, and we'll stop. Perfect. Now I just need to make this move to the middle, and there we go. Lovely. So that's an easy way for us to add a single staircase. But what if we want to go a lot larger? Well, I can just simply select this again and do what we've done already with our brushes. Hold down Alt, drag, let go, and then I'll just move it up. And you'll see here, quite an easy way to get some steps showing up. And finally, I'm just going to add one more object by dragging this out and then dragging it back up. And finally, I'm going to look at this player start, and you'll notice that there's an arrow underneath it, this arrow right here. That's pointing in this direction. That's the position where I'm going to start from. But I want my player to face this wall. So I'm going to switch to rotation, and I'm going to rotate it around 90 degrees. Finally, I'm going to go and build everything. And with all that done, I'm going to hit play in editor, and there we are. We've got our nice rooms that already look much better in this nice mesh already. So from here, I'm sure you can add any other kind of additional meshes that you'd want to make your level pop that much more. Hello and welcome back to UDK Game Development. My name is John P. Doran and this is Section 2, 3D Platformer, Part 2, Creating Collectibles. Over the course of this section, we're going to learn how to build a collectible. After that, we're going to create Kismet pickup behavior. Then we're going to learn how to use named variables. And then finally, we're going to learn how to create prefabs. So with that in mind, let's get started. In this video, we're going to add our first custom feature to our platformer game, a collectible item. So in between the last video, I spent some time actually building an area that we could jump around in, as you can see here. Now, feel free to spend time creating your own design, or pick up the file that I created at packedpublishing.com at the address shown on the screen. And for those of you who'd rather like to see the exact process, you can actually watch the video at this link. Now, in games, collectibles can be used for a lot of different things, such as rewarding the player for exploring the world, and to lead the player in directions he'd otherwise not know how to go to. So in our game, what we're going to do is we're going to make it so that we can we're going to pick up all the collectibles in our level, and then we can complete it. So the first thing we need to do is to actually find a 3D model, or as we call them in UDK, a mesh, to act as our collectible. So to do that, I'm going to go into the browser window and select Content Browser, and then I'm going to have to look for one. So for that, I'm going to go to this object type here, and I'm going to be looking for a static mesh, and I want some kind of pickup item. And we've got a couple different things here that we can use. Let's see. Okay, I think this will work out nicely. So with this object selected, we need to put it inside our map. So I'm going to go somewhere in my level. I can either close the content browser or just move it aside. I find a place in my level, and wherever I want to place it, I need to go right-click, and then select Add Interp Actor, Pickups Ammo, Shock Mesh, S Ammo, Shock Rifle. With that done, you'll notice that down here, you'll see that mesh. The Interp Actor, or interpolating actor, is a special dynamic version of the static mesh actor that we've used previously. It supports a wide variety of physics types and can be controlled via Kismet or in Matinee. Now, in previous versions of Unreal Engine 3, it was referred to as a mover. So if you see something using the word mover, they're talking about the same thing. Now, the reason that we're using an interp actor is the fact that static meshes can't change once the game starts due to the fact that they're, well, static. Interp actors, or movers, can be moved as well as be made invisible, and that's what we'll be doing. Now, if you looked at the browser, you'll notice there's that section here where it says no collision model, and that basically means that there is no collision on this object, so we're not going to be able to actually tell whenever it is that we've collided with it. So what we're going to do is we're going to use something called a trigger volume to call an event using Kismet so that when we touch it in the same area where the mesh is, then we're going to make it disappear. So to do that, we just simply need to duplicate another brush like we've done in previous videos. So go over here, find a mesh that we want to use, drag it over, again, holding down the Alt key, and we'll just very quickly put a box that will hold the entire object. And there we go. So finally, I want to make it only be as tall as we need for the actual object. And there we go. I think that'll do nicely. Lastly, we need to go into the properties for this mesh and change it to be the actual volume. Now we can do this by right-clicking and then selecting Convert to Volume, and then you'll see Trigger Volume. And now you'll notice that the color changes from that bluish color now into this green one. Now, as you saw earlier, there are actually many different kinds of trigger volumes that you can use. Right now, we actually used a brush that we've created to turn it into a volume, but we can also create another brush by using the builder brush from before. Again, I can press B to bring back the builder brush, and if I go to this menu here for volumes, click Add Volume, you'll see that all the volumes are here as well, including the trigger volume once again. Now, we're not going to be talking about all the different volumes that there are inside of Unreal. If you're interested in learning more about volumes, you can also check out the UDN here, and it'll have more stuff all about volumes. So finally, we want to add something so that once we collide with this, instead of just going invisible, we want a little extra pop to our level. We want to see some kind of effect. To do that, we're going to use something called a particle system. Particle systems are a way to create a lot of cool graphical effects, such as fire and explosions, and that's what we're going to use for this. So to do that, I'm going to once again go to the content browser, and instead of using static meshes, now I'm going to be unchecking this and selecting particle systems. And instead of a pickup, I want to have some kind of cool effect. I've already went ahead and found one that I really liked. The shock rifle explosion effect. Now you'll see it right here. With that selected, I'm again going to exit out of here, then right-click where this is, and click Add Emitter. Once that pops up, you'll see that huge explosion. Now I want to move it until it's in the center of the mesh. Now, if you need help doing that due to being on the grid, you can uncheck right here until you move it into the correct position, and then afterwards, we can turn it back on. Alright, I think that's pretty good. Now, by default, if I play the game, the particle system will show up as soon as the level begins. And that's not what we want. We want the particle system to only play once I collide with that collectible that we've created. So, to do that, with the particle system selected, I can go into the properties window for the actor by pressing F4 or going there, and then we want to turn off the property Auto Activate. Auto Activate says that I will start as soon as the level turns on. So I'm going to turn that off, and now when we start the game, you'll see that it doesn't happen. Alright, so at this point we now have the object in the world, but nothing happens whenever we touch it. And so that's what we're going to do in the next video. In this video, we're going to see how we can use a trigger volume to have a sound play, hide the item, and then show that particle system whenever it is that we touch our collectible. So as of right now, we have this coin in our world, but it doesn't actually do anything. Let's change that. So let's go back inside of Kismet, and now we're going to create a new subsequence to hold our coin's behavior. So to do that, I need to go somewhere along this area, or anywhere we want, right-click, and then select Create New Sequence. Once this pops up, it's going to ask us for a name for this subsequence, and we're going to call it Coin Pickup. Now, if you'll notice that this sequence is like a folder. It allows us to hold different kinds of behavior. It allows us to separate different pieces of functionality. Now, one of the other cool things about this is that we can separate the functionality of prefabs, but we're going to learn more about that in a later section. Now that we have this new sequence created, I want to go back into the editor, and then I want to left-click on the trigger volume, because we're going to create an event using it. So, with it selected, we're going to go back into Kismet, and then I'm going to right-click, and you'll notice that now we have this new menu, new event using trigger volume 0. So the trigger volume will let me know whenever I collide, whenever I touch that trigger. So I'm going to select this touch event right here. Now, when trigger events are first created, they come with some properties that contain default values, and one of them that I want to talk about is the max trigger count. You'll notice that right now, this is set to 1. This is how many times that the event can be activated. This is fine because we only want to collect this once and then it's going to disappear. But if we ever want to have an event happen an infinite number of times, we can just put 0 there. Now that we have this touch event created, we need to have access to our coin's mesh. We need to, so that we can disable it. So with this mesh selected, we then go back into Kismet. From there, we need to create a toggle hidden event by right-clicking to the right of this touch event and then selecting New Action, Toggle, Toggle Hidden. Now, we want to connect the touched from the trigger touched event to the hide of the toggle hidden action. So we want to hide something when we touch this trigger. And what do we want to make invisible? The object. So under the target section, we want to create a new variable that will hold our interp actor that we've created. So I'm going to right click here and then select new object var using interp actor 0. And again, the reason it says interp actor 0 is because it is selected. And then I can just go from the target and connect them. Now, if I didn't want to do this in 2 steps, I'm going to delete that by hitting the delete key. I can just, with this highlighted, right-click and then say new object var using interp actor 0, and you'll notice that it's already connected to us. So, just to verify that we've created a variable for the correct object, let's just double-click on this value. You'll notice that the screen moves to that object. And the same thing will happen with the trigger volume. The next thing that we're going to want to do is we want to add a play sound action. To do this, we're going to need to right-click once again and select New Action, Sound, and then Play Sound. After that, we're going to connect the out from the toggle hidden event to the play of the play sound event. Now, we don't know what sound to actually play, and that's because at this point, play sound, the sound that we want to play, is set to nothing. So in order to find a sound to play, we're going to once again go back to the content browser. So from there, we want to find a sound to play. So to do that, I'm going to check sound cues, uncheck particle systems, and clear this out. Now, you can double click on any of these sound cues, and you should be able to hear exactly what the sound sounds like. So I'm going to pick a sound. That sounds fine. So with this selected in the content browser, I can go back into Kismet and then click on this green arrow here, which will use that object inside of the browser. So now, the event, once we touch the object, it will turn this off, and then it will play a sound. But it doesn't know where to play the sound. We're going to have to use the player variable in order to have the sound play where the player is. So to do that, underneath target, I'm going to right-click and select new variable, player, player. There we go. And then connect the target to there. Now, it doesn't matter because this is a single-player game, but if I wanted to specify a particular player, I could uncheck all players and then give a certain ID. Now, lastly, we want to actually turn on our particle system. So in order to do that, we're going to create a toggle action by right-clicking and then selecting New Action, Toggle, Toggle. And then finally connect the out to the turn on of the toggle event. And just like last time, we're going to go back into the level, select our emitter, and then create an object using it by right-clicking and creating a new object variable for it. Now, if I want to clean this up a bit, I can do a marquee selection around different areas, and then I can hold down Control and drag this around to make it look a little nicer. And I'm going to do that real quick. Now at this point, if we play the game, we should be able to see everything work perfectly. So I'm going to do that real quick by closing out, going to play, and then going into the editor. So now, when I step up near this, you'll see that we have that effect happen, and now it's completely invisible. However, there's still a couple of things that we'd like to do, such as knowing how many coins that we've collected. And that'll be what we do in the next video. In this video, we're going to show to the player just how many coins they've collected over the course of the game. So in order to do that, we're going to have to learn about how to use named variables. So now our coin pickup now works perfectly, but now I want to know how many coins I have collected, because once I collect all the coins in the level, I can then move on. So to do that, we're going to have to learn a bit more about Kismet. So we're going to go back into Kismet, and then instead of being in the coin pickup sequence where we were earlier, we want to be in the main sequence where everything is. And I can click here to see that if we're not there already. So the first thing that we're going to want to do is we're going to want to create a new integer variable, which UDK calls int for short. Now an integer is basically any whole number value, so no decimals. And that's perfect for storing the number of coins we've collected. So to create an int, we're going to need to right-click and then go to New Variable, Int, and then Int. Now, if you'll look at the middle here, you'll notice that the value of this integer is now 0, which is perfect because we haven't collected a coin yet. But if I ever wanted to change the value of the object under int value, I can type in whatever I want. So here, if I type 10, it becomes 10. So I'm going to change it back to 0. Now, if we left-click on the object to select it, you'll notice that the property windows show up for this object, just like every other object. Under the sequence variable section, you'll see this var name variable. We're going to actually type in a name here, so instead of none, we're going to put in num coins, number of coins. And you'll notice that once I hit enter, now that text shows up on the screen. Now by giving this variable a name, we're allowing anything inside of this sequence or inside any child sequence, like coin pop-up, to be able to access and use this variable by using something called a named variable. So let's do that now. So inside your subsequence that we made in the last video, at the very end, we want to create an add int action, an add integer action, by right-clicking and then selecting New Action, Math, and then Add Int. This gives us 3 different variable links, which have A, B, and then int result. You'll notice that the shape is different on the int result, and that's because it takes the values of A and B, adds them together, and gives us the int result, which is the actual result of the addition. Now what we want to do is we want to add 1 to our numCoins variable that we've created earlier. So to do that, first, under B, I want to create a new int variable with a value of 1. So to do that, I'm going to right-click, create new int variable, and then select 1, and hit enter. Now we want to create a named variable, so that we can access the num_coins number anywhere inside of our code. So to do that, I'm going to right click and then select New Variable, Named Variable. Once this is up, you'll notice this big red X and a series of question marks showing up. That's because it doesn't know what variable we're trying to talk about. And we can fix this by once again going inside of its properties. So under there, under sequence vars names, you'll notice that there's an expected type and a find var name. So we're going to change find var name into num_coins. And when I hit enter, now it's giving me a check. Now you'll notice that the color here is this blackish color, but if I change the expected type to int or connect the A to this, it'll change the actual color. Now, when that's connected, and then we connect the out from the toggle to the in of the add int, this whole event should carry out. So just to confirm that everything is working correctly, let's print the value of our coin to the screen. So in order to do that, we're going to need to create a log action. So to do that, we're going to need to right-click and select New Action, MISC, and then Log. Under Target, we want to put our player variable like before, so New Variable, Player, connect that there, and then connect the out to the in for the log variable. Now, what we need to do next is the log variable will only let us connect something if we expose that variable inside of the action. So in order to do that, I'm going to right-click on this action and select Expose Variable and then int. And that's going to give me this int that I can now put there. So when I connect here, this int to num_coins, after this happens, it's going to print out the value of num_coins. So I'm going to close this out, and then I'm going to hit play and then in editor. And then I'm going to walk over here. And you'll notice the value is 0. Now, why is that? Well, if you go back into Kismet, you'll see that we do indeed add num_coins in 1, but we don't set the actual result. So to do this addition so that we're incrementing the value of num_coins by 1, we need to have num_coins be the int result as well. So it's going to go from 0, 0 plus 1 becomes 1. To see that, we're going to go play the game again, go back through the editor, walk on through, and you'll see that the variable is now 1. Now at this point, you should see 1, and now when we collect a bunch of different coins, we'll be able to see all of them that we've now collected. And now we can create a bunch of coins, which will be quite useful, and we'll now learn how we can use prefabs to do this quite easily in our next video. In this video, we're going to make it very easy to add additional pickups into our level by making use of prefabs. So right now, we have one coin, and it's working quite well. We even have a way to track how many coins we have collected. However, games typically reuse assets in order to reduce the time needed to actually make these items. Now, we could very easily make it so that we can duplicate our coins many times using prefabs, and that's what we'll be doing now. To do this, we're going to need to go into the editor and then select all of the actors associated with our coin. So we need to select the trigger volume, hold down Control, and then select the emitter, as well as our mesh. Now with everything selected, I want to right-click and then select the option Create Prefab. Now once we've selected this, you'll notice that there's this menu up here that asks us for a package name, a grouping, and a name. So the Unreal Engine has this concept of a package. which is a file that contains all the various types of game assets that we can use within our level. So these assets include all the textures, the stack meshes, the materials, the skeletal meshes, the physics assets, AI scenes, and more. Anything that can be added to the game engine can be put into a package. Now, one thing that's important to note, levels are represented as a special kind of package which contains references to assets that are inside of those package files. This allows the sharing of assets across many different levels and allows an artist to change the asset one time in the package file, and then all the levels that reference it will be automatically updated. So under package, any name that you like, but what I'm going to do is I'm going to name it Game Dev Tut Assets. So Game Tutorial Assets. And then for the object's name, I'm going to put in Coin Pickup. So with that done, I'm then going to press OK. Now after that, we should have a dialog saying that it found a sequence using those items. That Coin Pickup subsequence that we've created in the last section. Now if you see this, we should say, yes, we do want to make this sequence part of our prefab. After that, it'll ask if we want to replace our coin to be a prefab. And so I'm going to say yes once again. And now you'll notice that the object looks the same, but now there's this big P symbol showing up there. Now this P won't be shown up in the actual game, but it is a visual indicator to make sure that you know that we have a prefab there. So the first thing I want to show you is that if you select this object, everything's highlighted, and I can right click and then select Find in Content Browser. You'll notice that once it finishes loading, that coin prefab object that we've created is right there. Now, it's very important that you actually save this package, or if you leave the game or UDK crashes, you'll lose the assets that you've created. So to do this, I'm going to close this out, select my package, right-click, and select Save. If that's done, you need to save it somewhere. I usually suggest that you keep it somewhere within the content folder. I typically put it inside of my Maps folder. So with that, I'm going to hit Save. Now, just like we've placed meshes before, we can do the same thing with prefabs inside of our content browser. So I'm going to type in Coin Pickup. Once again, left click on it, then go anywhere in the world that I want, right click, and then select Add Prefab. And you'll see that the object is right there. It's already been placed for us. We can also move them just like any brush. So I can hold down the Option key with this one selected and drag it out. Now the really nice thing is that whenever we do this, all the Kismet that we've written previously is also created a copy of, so that the coins will do the same actions that we did in the last section to add to our num_coins variable. So finally, I want to make sure, because we've added a trigger volume, that we build everything first. So I'm going to go to Build All, and then I'm going to try it out. So with this done, I'm going to close out and then go back into play. So now we have these multiple coins that can keep track of how many's been collected. 2 and 3. And this is a fantastic start to building our game, but let's add some additional functionality that isn't found in the base UDK game. A checkpoint system, which is what we're going to start working on in the next section. Hello, my name's John Doran, and welcome back to UDK Game Development. This is Section 3 Platformer Part 3, Implementing a Checkpoint System in Kismet. Over the course of this section, we're going to take a look at setting object variables at runtime, building our checkpoint, implementing that checkpoint's behavior, and continue our look at prefabs. So with that, let's get started. In this video, we're going to begin to build a new gameplay element to our game. That being a checkpoint system, which will be quite useful when you increase the length of the game on your own. Now at this point, we're starting to see a 3D platformer game. But right now we still don't have much of a problem if you die or you fall off while you're playing the game. So in order to fix that, I'm going to go to View, then World Properties, and then I need to set this kill Z value. Right now it's this really huge number, so instead I'm going to make it something like -200. Now if we zoom out here, you'll see that there's this red line. Whenever I cross that line, I will die. Now let's start up the game, and you can see we have a 3D platformer. We're able to walk and collect different things, and we're able to jump around. But if we ever die in the game, like the following, when we restart, we always get brought back right to the center. Now rather than doing this all the time, let's spawn the player back to a key point that they visited so they don't lose all of their progress. Now this will be especially important when we start having really, really large levels or multiple levels inside of our game. This will also be a very good refresher on the stuff that we learned in the previous section about how we can use the same tools to do different things. Now to start off, we're going to need to go into Kismet to create a new object variable with a name of newSpawn. So to do that, we'll go into Kismet and we'll create this new variable. New variable, object, and under the sequence variable, we'll change its name to newSpawn. After we do that, we want to initialize our newSpawn variable to be set to the player start that we begin when we load our level. To do that, we're going to need to create a level loaded event by right-clicking and selecting New Event, Level Loaded. So when the level loads, next we need to create a set object action. So to do that, I'll be right-clicking once again, selecting New Action, Set Variable, and then Object. Now under the Set Object function, you'll see that we have two variables that we can use, the value and the target. So we'll be assigning whatever value is to our target variable. So our target is this newSpawn variable that we've created, and our value is going to be our player start. So let's exit out and find our player start in our actual level, which is this icon right here. That's where our player spawns from. So I'll go back into Kismet and I'll right click under value and create a new object var using player start 0. Now we could just connect the newSpawn variable right here like this, but instead I'm going to use another named variable. So I'm going to hold Alt and click to get rid of that, and then I'm going to go right click New Variable, Named Variable, and then just to show once again, newSpawn changes to a check, and when I connect, turns green. Finally, we want to set this at the beginning of the level. So let's learn a new feature about UDK that we can use to help us with our projects, with that being visual debugging inside of Kismet. Now what that allows us to do is it allows us to stop the game, pause it while the game's going on, so that we can walk through what goes on in our code as well as verify the values of variables that we have set inside of it. This is extremely useful when you're trying to figure out exactly what order your code happens and to make sure that everything's working the way that you want it to. Now, in order to do this debugging, we need to set breakpoints in which we can pause the game. In order to set a breakpoint, I just simply need to hold down the Alt key and click on any event or action, like I'm going to do here for this set object event. Now, by default, if I just go and play the game, nothing is going to happen. However, if I toggle enable Kismet debugging before I play the game, now you'll see the game stops because it's been paused because it's reached this time. And you'll see that it's been activated once. And also, the player spawned has been activated once. One thing you'll also notice is that because it's been activated, the value of new spawn isn't question marks or null. Instead, it's player start 0. Later on, if you want to do more things, you can use these buttons here to move or continue or step through whatever's going through in your code. So when I hit continue now, the game continues as normal. This can be a quite useful thing to use when you're working on more things for your projects. Now, we have our variable set. This will be very important when we're setting up new spawn points, which is what we're going to be working on next. In this video, we're going to see how we can spawn from a new player start instead of the first one after we reach a checkpoint. So the first thing I'm going to do is I'm going to turn off this breakpoint by holding Alt and clicking to turn it off, and I'm going to disable the Kismet debugging. Now, in order to register that we've reached a new checkpoint, we could use a trigger volume like we did in the previous example, but this time I'm going to make use of the trigger class instead. Now, the trigger class does some very similar things to a trigger volume, but unlike a trigger volume, instead of being a box, it's a cylinder. In addition, we can also create events such that we have to look at the center of a trigger in order to activate it. So it can be useful for things like a button. To create a trigger, we'll need to go into View, Browser Windows, and then Actor Classes. And then we need to select the trigger. Now, I can see this right here, but I wanted to point out that once again, like everything in UDK, you can type in whatever you want in the search bar, and you can see everything that has trigger here. So when I have triggered selected, I'm going to close this out, and I'm going to find a place where I want my checkpoint to be. Right click, and then I can move with WASD, like an FPS game, and I want to create a checkpoint here. So I'm going to right click, and then I'm going to select Add Trigger here. And now you'll see it shows up. So the player will have to be inside of that green area in order for our event to trigger. Now right now it's pretty small, so I'm going to scale the object up. Normally I'm not that big of a fan of the scaling tools because it makes it very hard for us to stick to the grid. But for something like this where it's just a radius and it's only behind the scenes, it's pretty much okay. So to scale the object, right now we have the translation gizmo showing up, but I could press the spacebar to move it to rotation and then scaling, or I can use here, I can click on this for a uniform scaling, or this for non-uniform. So what I'm going to do next is I'm going to grab this, make it larger, and make it a little taller. We'll scale it up just a little bit more for size. Now, after we have this, we want to place a new player start in that same position. So to do that, it's actually quite simple. I just need to right click and then select Add Actor, Add Player Start. Now, a player start is actually a path node, or it inherits from a path node. So in order to use it, we need to make sure that we build paths in our game. So in order to do that, I'm going to go to Build, and then AI Paths. Alright, so now that we have this done, what we want to do is that when the player hits the trigger, we want to spawn to this player start instead. So the first thing that we need to do is we want to turn this player start off by initial, because otherwise Unreal will choose randomly one of these two spawn points in order for our player to spawn from. So in order to change that, I'm going to go into the actor properties, and then I'm going to go to the enabled property, and I'm going to disable it. So this is no longer enabled. Now, at this point, we have the checkpoint built, and when I play the game, we can't see it, but it's there. Now, in the next video, what we're going to talk about is how to actually make this functionality happen. And to do that, we're going to dive once more into our good friend Kismet. In this video, we're actually going to implement the functionality of our checkpoint making use of Kismet. Now, for just 2 checkpoints, we can simply make it so that whenever we get to the trigger, I turn the first one off and the second one on. But what if we're working on a huge game in which we have 30 different checkpoints? In addition, depending on the path that our player takes, they may skip certain checkpoints altogether. So what we want to do is that whenever our player reaches a new checkpoint, we want to turn whichever one is currently on off, and then turn on the checkpoint, the player start that's at the checkpoint that we just hit. So the first thing that we'll need to do is we'll need to create a touch event for our trigger, much like we did for the trigger volume, by first selecting it, then going into Kismet, and then right-clicking and creating a new event using trigger 0, touch. Now by default, this touch event will only be activated once, because again, max trigger count is set to 1. Now, if we want to make it so that when we touch a checkpoint every single time it goes back, we can change this to 0. So anytime we go to this area, we will change the spawn point for there. So that's what we'll do for this time. Next, we're going to need to create 2 toggle actions, one to turn things on and the other to turn things off. So to do that, I'm going to right-click and select New Action, Toggle, Toggle. And then I'm just going to Control-C, Control-V to create a copy. Now, after that, underneath the first target, we're going to want to put the named variable of our new spawn object. So I'm going to go into New Variable, Named Variable, and New Spawn. And there we go. The second one, we're going to need to put the player start that we've created in the last lesson. So I'm going to select the player start, unclick and click, and then create an object using that. Finally, we're going to need to create a set object action to make the value of our new spawn variable be our new checkpoint. So to do that, I'm going to right-click and select New Action, Set Variable, Object, and then our value is going to be our new player start, and the target is going to be New Spawn. So when I touch my target, I'm going to turn off the enabled on whatever is my current spawn point. I'm going to turn on the new one that I have, and then I'm going to say that New Spawn is that our new player spawn variable. So when we hit the next checkpoint, then it will turn that one off, and then turn ours on. So again, we'll just check and make sure everything works. So I'll go into the game, and when I click here, now when I die, I start back up here. Now, you'll notice that I'm turned this way instead, and that's because the player start that I've created is facing in this direction. But in reality, I want to be facing the direction that I want to go in next. So I'm going to rotate me over in this direction. We changed the paths, so we need to make sure to build our AI paths. And then when I go in to play the game again, you'll notice once again, when I die here, I spawn back here. When I die after touching here, I get spawned back, and I can see where I need to go next. Now, just like we did with the collectibles, we're going to be turning this all into a prefab. So we need to use all that code that we used earlier in our Kismet sequence and put it into a subsequence. This is quite simple to do, even though we didn't make a subsequence earlier. All I need to do is do a marquee selection. And again, that's Control-Alt, select the objects that we want, then right-click, and then create new sequence. So I'm going to do that, and then I'm going to give it a name of checkpoint, and I'll hit OK. Now, there we go. And with that, we have one checkpoint completely done. In the next video, we're going to learn how to spawn many of them again, diving more into prefabs, and also talking a lot more about packages. So right now, we have one checkpoint, and it works very well. So let's quickly add in the checkpoints as a prefabs as well. So again, inside the editor, we're going to select all the actors associated with our checkpoint. So that is our player start and our trigger. As a little other thing to note, if you ever see your arrows not in a straight way here, that's because it's in a local frame rather than in the world frame. And in order to turn that back to the world, you can hit the tilde key. So again, I'm going to hold Control, select both objects, and then right-click, and then select Create Prefab. Once again, you'll get options asking for the package name, the grouping, and the name. Now, before we continue, I want to touch a little bit more about packages before we move on. Now, don't just use the same package for every little thing that you do. When you start working with multiple people on the same project, you don't want every single person grabbing stuff from that same package. My suggestion is to have a package for each type of file in your game or your environment. That being said, also make sure your packages don't get too terribly big, or they won't work on some platforms. My suggestion is that you should not have any packages going over 200 to 300 megabytes. Now, if you're interested in learning more about packages, you can check out the UDN. And inside of the UDN, you'll find all kinds of information about packages, the naming, the way that Epic does it, and more stuff that may be useful to you as well. So, under package, I'm going to put in game dev tut prefabs, and for the object name, I'm going to put in checkpoint, and then I'm going to press OK. Again, it's going to find that subsequence that we've created earlier. We're going to say yes. Then after that, we're going to say yes once again to make ourselves another prefab. So again, just like before, you want to make sure that you can save this package. So right-click and save. Wonderful. Now let's make a couple of other checkpoints in our level in places where we think the player may get stuck. Like, for example, I may think that this is pretty easy, and I'm going to Control-C to copy this, but maybe getting over here is kind of an accomplishment. So I am going to paste that object right over there. And I will move find our checkpoint, then I'll create a checkpoint right here. And if you see this bad size, that means you need to raise it up some because it's going to spawn our player in the wall. Finally, I'm going to add one more over here. So again, bad size, move it up. And our other one, I need to move up as well. One thing you can do is you can actually hit the end key, and this will actually drop it down as well. So after that, like before, we want to make sure to build everything. Now when we play the game, we now have multiple checkpoints that will spawn us in whichever one was the last that we touched. So here I touch this one, I die, and now I'm positioned here. I touch here, and I die, and now I'm spawned here. Now at this point, we can work on making our game now have multiple levels using this checkpoint system, which is what we're going to be discussing in the next section. Hello and welcome back to UDK Game Development. My name's John P. Doran, and this is Section 4, 3D Platformer Part 4, Level Streaming. Now in this section, we're going to take a look at how to make a persistent level, how to set up streaming volumes, and finally how to shift to additional levels. So with that, let's get started. A concept that most games have are the idea of levels. That is to say, games typically consist of multiple levels, which each level having a different experience inside of each one. Now, there are a couple different ways in which you can load levels inside of the Unreal Engine. The first is to make use of a console command. To load levels via a console command, I'm going to need to go to Play and then on PC. This particular way of loading levels will not work inside of the editor. So the only way that you'll be able to see this actually working is inside the actual game. So at this point, Unreal is now loaded up. This is the equivalent of the game being run on the PC, as in what we'll be using for our final product. Now, if I open up the console window, making use of the tilde key, I can then type in the word open, space, then a name of a map inside of my world. For example, here, I'm going to use the example map that Epic provides to us. You'll see here, now it goes to a loading screen, and now if I turn that off, you'll notice that now we're here, we're inside a level. Now again, this is work, but it brings us to a loading screen, and it doesn't work at all for playing inside the editor. Another way to do it is using the concept of using streaming volumes to load levels in and out during runtime. So I'm going to get out of this game here by pressing escape, going to quit, and then going to exit again, and hitting yes. If that doesn't show up for you, you can Alt-Tab of the program, and then right-click and then select Quit. The use of streaming volumes is how a game can have many different levels inside of it, but never appear to have loading times at all. The basis of this is the idea of a persistent level. The persistent level can be thought of as a master level, which we'll use to govern which levels will be streamed in and out, and hold any data that needs to exist in all of our levels, such as the number of coins that we've collected. So to do this, we're going to use our level that we have right now as the persistent level, moving over all of the things that we've created into a new map. So to do that, I'm going to right-click, and then I'm going to select all, and now everything in my world is now selected. However, we will want to keep the first player start and all of our checkpoints to be part of our persistent level. So with them, I'm going to hold down the control button and then left click on that object. And there we go, that's unselected. And then I need to uncheck all of the prefabs we made in the last video for our checkpoints. And we have one more here. There we go. So once this is done, we now need to go to the Levels tab of our browser windows. And we can do that by going to View, Browser Windows, and then Level. Once here, you'll notice that we have a persistent level. Now usually, whatever level you have open at any time is considered to be the persistent level. But now, let's learn how to add another one in. So here, I'm going to select Level, then New Level from Selected Actors. At this point, we're going to save a file in the same directory of our persistent level. I'm going to call this level Game World. Then I'm going to hit Save. And then when it asks what you'd like to load in the level, we're going to select Kismet as our streaming method. We'll hit OK. And then we'll see some actors are referenced. We will say Continue. Okay, so now at this point, we now have two levels that are in fact pieces of what you've created previously. In the next video, you'll see how you can load both levels at once, making use of our level streaming volumes. In this video, we're going to learn how to load levels dynamically via our player's position using streaming volumes. Now before we go any further, because we're using brushes for our actual meshes, what I want to make sure we do is that we go to build all in both levels to make sure that everything shows up the way that it should. And then I'm going to switch to the persistent level by double clicking on it, and then going once again to build all. Alright, and there we go. And if we play the game, by default, all you're going to see is black. And that's because the persistent level, we have nothing there, except for blackness, which the player spawns at. Now what we're going to do is we're going to be creating something called a level streaming volume. And with that, we're going to be able to say that as long as my player is within this volume, within this space, have this particular level loaded. So to create the streaming volume, let's duplicate our light mass importance volume that's in our other level. So even though the volume's in another level, I'm still able to select this. Now if I hold down the Alt key and then drag up a bit, we've now created a copy. And then to turn this into a streaming volume, I'm just going to right click and select Convert to Volume, and then select Level Streaming Volume. And now you'll notice that it changes to this orange color. Any object that we always want to have access to will need to live inside of our persistent level. Now, since we always want our game to know when to have this level loaded, we need to move this volume into the persistent level because it and all other level streaming volumes always need to exist. So with this object selected, I want you to go into Browser Windows and Levels once again, and if this ever shows up with nothing at all, you can just switch tab back and it'll be back here. Now my current level selected is the Game World level. If you actually had the current level selected as the persistent level, the object may be inside of your persistent level, but right now if I toggle visibility, you'll see that the streaming volume isn't there. So to move it, I just need to select this object, make sure that my current level is the level I want to move it to, and then right click and select Level, Move Selected Actors to Current Level, and there we go. Now if I turn this off, you'll see that the game world exists or doesn't show up, but my streaming volume does. Now, with the level streaming volume selected, I want you to go back over here, right click on the world level, and then select Add Streaming Volumes. After that, let's jump back in the game, and you'll notice that everything works the way it did before. However, if I fall down, everything turns back to black. And that's because we exited our volume. Now, also one thing you'll notice is that if I walk up to the collectibles, all the code still works. And that's because everything that is available in the persistent level is available for all of the others. So now in the next video, we're going to work on having multiple levels being loaded and unloaded during runtime. In this video, we'll be working with multiple levels streaming in and out all at once. So one thing I wanted to point out before we continue is that if you play the game and you notice that you see all black, or if you play the game and it starts out fine, but then as you play, it becomes black. Like for example, if I go over here and then jump down, or if I fall down too much and it turns black, that's simply because the level streaming volume isn't where the player can get to it. So to solve that issue, I would suggest moving the volume down. Now, there isn't much benefit to actually having level streaming in your game if you aren't loading and unloading levels while the game is being run. So that's what we'll be doing in this lesson. So the first thing that we're going to do is we're going to be creating a new level. So to do that, I'm going to go back to the Levels tab. If this shows up as having nothing inside of it, just click on another tab and then click back and it should load up for you. So from here, I'm going to go into Level and then select New Level. From there, I'm going to give the level a name. I'm going to select Game World 2 and then I'm going to select Save. From there, it's going to ask us how we want to load the level. We're going to select Kismet again and then press OK. So this level, right now, will have nothing at all inside of it. So to change that, I'm going to double click on my Game World 2 so that that's now selected as my current level. And if I create anything, it should load up over there. So what I'm going to do is actually I am going to create an extended bridge into a secret area over on this side. So to do that, I am going to duplicate this mesh right over here. So hold Alt and drag it on over. And then we'll drag this out, make it much larger, and we'll make it so that there's a bridge between these two levels. So I'm going to select over here and drag it on out. Now, to make a level streaming volume that only works in this section, I'm actually going to extend this whole area out. So to do that, I'm going to do a marquee selection, and then I'm going to drag these guys out a bit. And there we go. And again, before we see anything, we're going to have to build all. But we'll have to do that inside our actual level. So with this selected, I'm going to make sure that it's located inside of the correct level. And if I unclick it and I toggle it off, looks like it's just fine. So finally, I'm also going to need to create another level streaming volume for this level. So I'm going to change the persistent level to be our actual game level, and then I'm going to duplicate this level streaming volume as well. And I'm going to move it right over here. So whenever we're in the area of this bridge, the bridge will be loaded in for us to play around with. And just to confirm that the streaming volumes are working correctly, I'm going to select the other streaming volume, and I'm going to change this position so that it loads out over here. So at this point, if the player moves over, it should get rid of everything except for this bridge. So with that in mind, let's build all and try it out. Now you'll see here that the level streaming volume has no level associated with it. So to set that, I just need to go right click on Game World 2 and select Add Streaming Volume. Now if we go in and play, if we move on over and go to the edge, it should pop us through. Now the only problem is the fact that we fell down before we got there because this is on the top level and not the bottom level. So we could just fix that by duplicating this as well. So we'll do that. Finally, because this level will get unloaded, we also need to extend the area out one more time. So with that all built, let's try it one last time. And there we are. We now have access to the secret area that's only for us. And we can walk in and out. Now, we have a nice foundation for our actual game, but we're still missing that whole third-person aspect and some of the other advanced features that we can put inside of our game. So in order to solve that, in the next section, we'll be diving straight into UnrealScript. Welcome to UDK Game Development. My name is John P. Doran, and this is Section 5, UnrealScript Setup. In this section, we're going to take a look at installing and exploring UnCodex, using RealScript IDE, and finally compiling UnrealScript source code with a Hello World example. So with that being said, let's jump right in. Now we've learned a lot of things so far by building this game project. But to truly exploit UDK to its full potential, we're going to have to touch on RealScript. In this video, we're going to begin that exploration. So far, for everything we've done, we've been using Kismet to create all of the gameplay features. And that's great because it has a low barrier to entry and is often used by game designers for prototyping different gameplay mechanics. But if we have to do something in every single level, or we have something that's very complex, we need to delve into some code. And in UDK, we use UnrealScript for that. UnrealScript is a programming language that was developed and designed by Epic Games as a way for people to make it possible to modify what the Unreal Engine does without recompiling the game's source code, which was made in C++. Now, if you're wondering when would be a good time to use Kismet, when would be a good time to use UnrealScript, I wrote an article all about that on my website, which you can go to right over here. For newcomers as well as veteran programmers, reading someone else's code is often the majority of your job. After all, you don't want to rewrite something that's already been written for you, unless you have a valid reason to do so. Having an understanding of the code base that you're working on is paramount to writing code that doesn't conflict with stuff that's already been written. In order to help you when starting out, I have a tool that you can use that you can integrate into your daily workflow that should make your life using UnrealScript that much easier. The first tool is called UnCodex. UnCodex organizes all the 2,000 plus files that are located within our UDK's development/source folder and displays them in a way that's easy to see the relationships between each classes. So to do that, we're going to open up a web browser of your choice and go to sourceforge.net/projects/uncodex. Once there, I want you to click on the download button. As soon as the project finishes downloading, I want you to double click on the setup and put it on your file. So here I'm going to select Save, and there we go. We'll hit Next, read this agreement, and if you agree with it, go Next, install in a directory. We'll leave in the default installation, put it here, and should be fine. Once it's finished, make sure that Launch on Codex is checked, and let's click Finished. Now, we'll get this config dialog box asking me if we want to edit the settings of our program. We're going to select Yes. At this point, we'll get the UnCodex window to pop up at the Source Paths option. Now, let's select the Add button, and then select from our UDK install the development source folder. So if you went through with the default installation, you can go to C, UDK, select your UDK install, and from there select development, and then source. And once that's done, hit OK, and then after that, we'll hit OK once again. It'll ask us to confirm that we want to scan the source paths for the packages and analyze the UnrealScript classes. We will want to click on Yes. Now at this point, you should see UnCodex scan and organize all the files within our folders and display them for us to see. At this point, you should see that UnCodex has now been configured properly and is now available for us to use. Now, let's go over what UnCodex is and what it's actually showing us and what it can be used for. The window on the left-hand side shows each package in our source file and each of the classes associated with them. If I drag this over here, you'll see that all the classes that are part of this package are shown here. We've already worked with packages already inside of Unreal. Just like we create a package to hold our prefabs, we also have packages that hold our classes. A package acts similarly to a folder inside of Windows in the fact that it holds things that we can use them. In the middle here, you'll see the class tree, which organizes each of the objects in the game based off their relationship to each other. You'll notice that there are different drop-down menus that show the relationships between classes. Now, we'll be talking a lot more about this when we dive into creating our first class, which we'll be creating in section 5.3. On the right window here, you'll see the actual code for whatever item we have selected. Unlike opening the file within a text object or an IDE, you'll notice that there are some hyperlinks inside of these files. And if we click on any of these hyperlinks, it will take us to that particular class. Like for instance here, I click the object class, it brings me to object. For those of you who are programmers or know how to read code, and you're interested in taking a look at more how UnrealScript is used, I suggest taking a look at the object, the actor, the controller, the pawn, and the weapon scripts. And that'll explain how a lot of things in the game are done. If you aren't, no worries, I'll be explaining things as we go along. There are a lot of other functionalities within Uncodex that are quite useful to us, but I leave that for you to explore. Just know that as you get familiar with UnrealScript and write your own code, this will be quite a useful tool for you to bring inside your workflow. For those of you who are wanting to learn more about Uncodex, you can check out the article on the UDN all about it right here. In this video, we're going to set up our integrated development environment that will provide a lot of nice functionality and make programming a much easier and enjoyable experience. Technically, all you need to do to write UnrealScript files is to open up the files in a text browser, like Notepad, and you can write whatever code that you want. And all the code that I'll be talking about will work perfectly fine just writing it in Notepad. However, programmers are inherently lazy. Otherwise, we'd still be writing in binary or assembly code. So over the years, we have developed tools to make our lives easier. If you happen to get a job working in the game industry that happens to use Unreal as their engine, as a licensee, you'll most likely be using Infringe and Visual Studio as your IDE of choice. And while Visual Studio does have a free version, it can actually be quite expensive to use Infringe for commercial projects, even for an indie game license. So with that in mind, we'll be using an IDE that is free for use and contains most of the functionality that Infringe provides, which is appropriately named RealScript IDE, and it's open source. So first, in your web browser of choice, go to the website where the project is at, uside.codeplex.com, and from there, click on the purple download button. Once the file finishes saving, make sure to double-click UnrealScript IDE install.exe file that's located inside of your downloads folder. It'll first ask if we want to install the IDE. We will say yes. Next, you'll see a question asking if you'd like to install the Microsoft Visual Studio 2010 shell. We're going to want to say install and wait for the download to finish. Once the download completes, you'll be brought to the Visual Studio 2010 shell download. Feel free to check or uncheck whether you're sending information to Visual Studio, and once it finishes setting up everything, click on the Next button. Once through here, read through the agreement and make sure to agree, and once it's done, click on the Next button. Once we get to the next page and it asks what you'd like to install, we're going to want to do a full installation of the program. Then we'll click Install. And there we go. The setup is now complete. So let's finish. The computer may ask you to reset. If it does, do so, and then run the installation for the IDE again. I didn't have that issue, so I'm brought back over here. So the installer will now guide us through the steps to install it. We'll just go on through, select Next. The next thing that you'll need to do is select where you want to install the program, and then we'll hit Next. The next section, it's going to ask us what our binary Win32 folder is of our UDK install is. Now, we need to set this to be our actual UDK folder. So I'm going to need to go to Browse, then go to C, UDK, select the version of UDK that you want to install to, then go to Binaries, and then Win32. Then click OK. After that, click Next, and then Next once again. Now, if you're unsure where your UDK folder is installed, you can go into your Start menu, go to All Programs, Unreal Development Kit, select this, and then right-click on your UDK editor program, and then select Properties. From there, you'll see the folder path to get to the Binaries folder. From there, you just need to add the Win32. And here we are. It's now successfully installed. And now you can click Close to exit. Go to your desktop and double-click on the UnrealScript IDE shortcut to start the program. And at this point, we now have our IDE installed and it's ready for us to use. Now this may look quite complicated at first glance, but just like UDK, it's very powerful once we learn a bit about how it's used. In the next video, we're going to write our first class using UnrealScript. Now that we have all the things required to write our code, it's time for us to write our first program. Since it was written 40 years ago, it's been a tradition for beginning programmers to print something, usually Hello World, to the screen as their first program. This will verify that everything is set up correctly and help us to learn how to output text to log files, which we can later use to debug or fix problems in our code in the future. So let's do that now. Back in the RealScript IDE, go to the Solution Explorer on the right-hand side of the screen. Underneath the UDK Config Project 1 section, we're going to find the default engine.ini file, and we're going to double-click in order to open it. Now, in order for our modification to the code to work, we need to add an additional package to be something that the compiler will recognize. So to do that, we need to open up the default engine.ini file, and once in there, we're going to use Control F to open up the Find window, and we're going to search for unrealed.editor engine. Once we get there, you'll see these two sections called plus edit packages. At the bottom of this section, we're going to add a new edit package, which we're going to call MyScripts. At this point, after we have added this package, we're done with the UDK config project. So I'm going to click on this little arrow here to shrink it back down. And now you'll see the other section of our UnrealScript code, or the actual UnrealScript code, which is our source project. Now, since we added that MyScripts package, we actually want to add it to our source project. So right here, I'm going to right-click, select Add, then New Folder. Once there, I want to create MyScripts. So I'm going to type that in. And you see exactly the same as what we used in the INI file. After that, we need to have another folder inside of this folder called Classes. So I'm going to go to Add, New Folder, and then create a file called Classes. Finally, let's add a script inside of here. So I'm going to right-click on Classes, go to Add, New Item, and then we'll pop open a window. Under here, we're creating an empty class in UnrealScript, and I'm going to give the class a name of Hello World Trigger. Once that's done, click the Add button. You'll now notice that the left-hand side has already given us a tab with our new file name and some default code already included with it. So I'm going to delete everything so that we can write it all from scratch. So the first thing that we need to do is we need to type in a class definition. That is to say, the name of our object and its relationship to other classes. So in order to do this, we need to add the word class and then the name of our class, which is Hello World Trigger. One thing to note, the class name needs to be the same as the file name we created. Otherwise, the compiler, which is what's used to compile our code and put it into the game, will give us an error. After this, we need to say what class we're going to be inheriting from. What class is going to be our parent. We use the extends keyword to say that we will use the class trigger as a base to add any additional functionality to our object. To get an idea of what I'm talking about, let's go back into Uncodex real quick. Inside of Uncodex, you'll see that class tree that we talked about earlier inside of section 5.1. You'll see at the very top we have this object class. If you click on any of the files below that, you'll see that it says that it extends from object. This is because those classes are inheriting all the functionality that's included in the object class. All classes must be inherited from another class, with the exception of the object, which everything else is built from. Now let's take a look at the trigger class. We can find it by either going to find class, or by typing in Control F. From there, I'm going to type in the query trigger, and then I'm going to hit OK. Now you'll see that the first trigger isn't actually the trigger class, but a trigger volume. So I'm going to press F3 to find the next result until we find our actual trigger class. And there we go. Now you'll see that the class trigger already extends from actor. And actor, if we click on this, extends from object. The idea of inheritance is one of the most fundamental things that we use as programmers. For more information on inheritance, check out the UDN's page about UnrealScript classes right over here. Now, after we say what we're extending from, we are then allowed to attach several optional specifiers that affect the class. Now, we'll be using the specifier of placeable, which is to say that our object should be able to be placed inside of our map. After we're finished, add a semicolon at the end of the state to say that we're done. Now you can actually indent placeable if you want, or you can also put it up here. This is what I typically prefer, but feel free to do whichever one works well for you, as long as the end has a semicolon. For a list of all the possible specifiers and what they do, check out this page once again under the Class Specifier section. You'll see all the different kinds of specifiers that there are. Classes are basically made up of two different elements, variables and functions. Variables hold data, whereas functions perform actions that typically use or modify the value of that data. Functions are basically a named set of commands that will be performed whenever they're executed or called. Now, we want to do something whenever this actor is first created. Thankfully, the trigger class has a function that does this for us called postBeginPlay. Now, to create the function, we have to create a function definition. The first line of the function defines how the function is identified and how it's addressed. This is called the function signature or its declaration. To create a function declaration, we first type in the word function and then the name that we want the function to have, which in this case is postBeginPlay. After we do that, we need to put an open and a closed parenthesis. This is the simplest kind of function that we can create. Later on, we'll discuss how we can expand on function definitions by using return types and putting parameters inside of here. Now, once we've created our function signature, let's actually write what we want the function to do. So to do that, we're going to put in an open curly brace and then a closed curly brace after the fact. And so I'm going to place it right here. In between these two curly braces is where the code for this particular function will be executed. Now, the first thing that we want to do is do whatever the trigger class did in this function. And I can actually look and see what the trigger class did for this function by going to my trigger class, right-clicking and selecting Go to Definition. And once I'm here, you'll see that if I go down, there's the postBeginPlay function. And here's the implementation for that. Now, I could copy-paste this into here, but instead, we'll be using super. Super is a keyword that allows me to use something of my parents. So in order to call my parents' postBeginPlay function, I'll just simply type super, then a period, and then the name of the function I want to call, postBeginPlay. Now, this is IntelliSense right here at the bottom, and it tries to help you to find what it is that you can actually type. Now, once I find what it is I'm actually wanting to do, I can just press the Enter key, and it will complete it for me. Now, after I've declared that I want to call this function, I then need to put parentheses to signify that I'm calling this function. After this, we finally need to put a semicolon to end this line. And we'll need to do that with every line inside of this function. Finally, we're going to print something. So to do that, we're going to make use of the log function. Now, to call the log function, I need to type -log. And the log function, instead of using nothing in between these two parentheses, we need to actually put in a string. But that string can be whatever we want. To create a string, I need to put 2 apostrophes and text inside of it. So in this case here, I'm going to write hello world. Now with this being done, our function is now, or our class is now completed. So I'm going to hit Control S, and then we're going to start the game. Now we can start the game by either pressing F5 or by clicking on this play button, but by default, playing the game will act as if we were running the game the same way that if from the editor we went to play on PC. It's going to be the final game and we're not going to be able to edit anything. So what I want to do is I actually want to open up the editor. Now you'll see if you go into your actual UDK file, your UDK executable, you'll see that for the editor, in Properties, the very end of this is the UDK executable and then the word editor. This is an extra command line prompt that you can provide to say, I want to start in the editor mode. And the other version of UDK, the game, is the exact same target, just without the editor page. So to run the game in the editor, we need to add that as a command, an additional command prompt. So to do that, I can right-click on my source project and go to Properties. From there, under Additional Command Line Arguments, I'm going to type in the word editor, and then I'm going to hit OK. And then after that, I'm going to press the play button to start compiling the game. Now with that, you can add any additional command parameters that you want. Now do note that all of them work except for -log, because the output is actually going to this output channel right here, which we'll be using later. Now, inside of UDK, everything looks basically the same as we had before. Now we're just in this normal default level. Now, let's add our new trigger to the level. So I'm going to go to View, Browser Windows, then Actor Classes. And if I extend Trigger, you'll see that Hello World trigger is now there because we've compiled that new code. So with it selected, I can right-click in this world and add a Hello World trigger there. Now, just to make sure that this isn't the default level, I'm also going to add a barrel or some object to my world, so that way I know for sure that this level is not the default level. And then I'm going to save this level so we can have access to it later by going to Save As, and I'm going to name the level Hello World.udk. And I'm going to hit Save. After this, we can just close out of UDK. And now we're going to open up the level inside of here. Back in the IDE, we're now going to go all the way up back to the source project again, and we're going to once again go to the properties. But this time we're going to use a more advanced command line prompt. So here I'm going to type in first the level that I want to load, my hello world.udk, and then I'm going to add some additional parameters to change the size and the position of my object at runtime, or at the time we start the project. So to change the X resolution, I can go to -resX is equal to 800. I can do res Y, and I'm going to set that to 800, 600. And then I'm going to also change pose Y, and that's going to move my object up or down, the window up or down, depending on what I want to do. And I'm going to change it to be -200, so it's higher up. After that, I'm going to hit OK, and then we're going to run the game once again. And this time, it's not going to load the editor, but it's actually going to load the game itself. Now it's going to pause here because we're in debug mode, but for right now, let's just hit the play button to continue on. You'll see here. Now it's loaded, and from the barrel and the need that we need to rebuild lighting, I know that I'm actually in my level with my Hello World trigger. But how else do I know? Well, as you can see here, there's a section called the output, and I pressed Alt-Tab to exit out of the game. I can also close the game by pressing this Stop Debugging button. Now if you look at the output, you'll see that there's a section that says Script Log with Hello World, which is exactly what we typed in that trigger, so if this shows up, our code should now work. Now, we've now written our very first class within UnrealScript, and we've also found a way to output information to ourselves that we can use while the game is running. Now, though you may not think it just yet, we've also learned a lot about how working with UnrealScript is. In the next section, we're going to be diving into some more complex programs to build additional custom functionality to our game. Hello and welcome to UDK Game Development. My name's John P. Doran, and this is Section 6, 3D Platformer, Part 5, UnrealScript Programming. In this section, we're going to take a look at how to create a custom game type, how to implement our pawn class, how to create our player controller, and finally adding in the camera zoom in and out functionality. So with that, let's get started. Now that we've touched on the basics of UnrealScript and you've written a simple class, let's write some game relevant script to really make our game shine. First-person games are great, especially in the fact that they can make the game feel more immersive because they're letting you feel like you are the protagonist. But when you're playing a platformer with different jumping puzzles, it's very important to make decisions based off of knowing where the player is. With a first-person game, it can be very hard to know where it is because you never know exactly where your feet or body are. What we'll be doing in this section is creating a third-person character as well as a camera system. We'll get started with the game class, which is the game type that is currently being played. So the rules of the game follows, or the rules that the game follows. To get started, we're going to create a new class inside of our MyScripts folder. So I'm going to right-click and select Add New Item. And then when we create the new file, I'm going to give it a name of platformergame.uc. And then we're going to hit Add. So after we add the script, it should show up for us right here. So the first thing I'm going to do is we're going to declare the class. So I'm going to say class platformergame extends, and we need to pick a class in which we're going to be extending from. So I'm going to put in simple game right here. Now we need to set some properties for the variables that already exist inside of the simple game class. To do that, we're going to need to use something called the default properties block. Now the default properties block is a special section in an UnrealScript class source file. It can define or redefine the default values for all of the properties that are declared in the class or that were inherited from a parent class. If a property is not mentioned in the default property block, the default value is inherited from whatever the parent class says. So if a property is not mentioned in any parent class default properties either, the default value is corresponding to the initial value of the property's type. Now, one of the things that you'll notice is that we will not use a semicolon in this section because it's optional. Now, UnrealScript is a case-insensitive language, so I can actually make any of these letters capitalized or not capitalized based on what I want them to be. Just for sake of clarity, I'm capitalizing the D and the P of default properties. So now after that, we're going to set two different properties inside of the default properties value. And those two properties are the PlayerController class and the default pawn class. And I've copy-pasted some code from stuff that I've done previously, but you can kind of tell what this is actually doing. I am initializing the PlayerController class variable to this particular class, and I'm initializing this variable to this particular class. And the classes are myscripts.platformerPlayerController and myscripts.platformerpawn. So this is saying inside of the package myscript, there is a class called platformerPlayerController and one that's called platformerpawn. Now we haven't written those yet, but that's what we're going to be doing in the next two videos. So now let's compile the game. But instead of pressing the play button or F5, I want to show you that we can actually go into our editor, same as normal, and if we change the source code of our game, it will say that the scripts are outdated and it will ask you to rebuild. So I'm going to say yes, and then it's going to compile everything. And you'll notice that this text and the text that normally happens in the output are exactly the same. So here we are, and you'll notice that there's a series of different warnings that are saying class property unresolved, invalid property in default. Those are created because the classes that I defined in the files don't exist yet. Thankfully, that's what we're going to be working on next. As you can see here in UnCodex, The pawn class is the physical representation of our player inside the game world. This class also contains the position and the rotation of the player's camera, which makes it perfect for us to use to create an orbiting camera. In this video, we'll be creating our own pawn class to take care of how the camera will work inside of our game. So first, we're going to go back into our IDE and create our new platformer class, our platformer pawn class. So I'm going to go right-click, add, new item, and just like we showed here, we're going to name it platformer pawn. And here we'll put platformer pawn. And we are going to be extending from the class simple pawn. Secondly, we're going to add some additional variables to make our lives easier. Variables are basically the properties that belong to a class. A variable consists of an identifier or name for a type of data that can be set and then modified while the game is being played. So to declare a variable, we first put the keyword var followed by the name of the variable. And then we type the name of the variable which we wish to use to identify this data. So for instance, I'm going to create the distance of my camera's offset from the player. So I'm going to put var float and then cam offset distance. And then I'm going to put a semicolon at the very end. Float stands for floating point number, which means that it's a number that can have a decimal place in it. I'm also going to put a comment here to let me know for sure what this variable is. Comments are things that we can use to help people reading our code to understand exactly what it is that we're trying to accomplish. So to put a comment here, I'm going to put slash, then a star, star, and then what I want to say, the distance the camera will be from the player, and then I'm going to close this by doing another star and a slash. You'll notice that if I don't close this comment, IDE will display everything as being green, and that's because the green value is being commented out. Now if I didn't want to have an open and close area, I can just put slash slash and that will comment out this entire line. Now let's create another variable for how high the camera will be. And I'm going to name that cam height. Now once we declare these variables, we need to initialize them inside of the default properties block. So here I'm going to put cam height equal to 64.0, again it's a floating point number, and cam offset distance equal to some other value, like 256. One thing that I want you to note is that in UDK, 1 foot is about 16 units. So here, saying the camera will be about 4 feet in the air and 16 feet away from me. Now that we have the variables that we need, we're now going to be replacing the functionality of these two functions that the current implementation of the camera uses to do what they want them to. Face rotation and calc camera. Face rotation is a function that we'll be using in the next video, but basically it tells our pawn what position it should face. Since we're overriding the function that was created by our parent, we need to use the same parameters that our parent does. So to take a look and see what it takes, let's go take a look at the class. So looking in the pawn class, we can see the face rotation function takes in two different parameters, new rotation and delta time. Delta time is a floating point number that represents the amount of time that's passed within this particular frame. But new rotation is a rotator, and the type of a rotator means that it contains 3 different numbers. a pitch, a yaw, and a roll, which allows you to specify a particular rotation. So I'm going to copy this function and bring it into my platformer pawn right in here. And then I'm going to open it and I'm going to close it. New rotation is set by default to where the pawn should face next. And again, delta time is the amount of time that has passed from the last time that we've called our update. Now, this is the amount of time that's passed since the last frame, which we won't be using, but we need to include because the parent version of the function has it. Now, we only want to change the direction if the player is moving. So the first thing that I'm going to check for is if the rotation is not 0 in the X, Y, or Z axis. So to do that, I'm going to write if normal acceleration is not equal to vect 0, 0, 0. So if my acceleration is anything other than 0, this code will get called. What the normal function does is it returns a unit vector, which is to say that its length is 1. A vect, or vector, is similar to a rotator in that it has 3 different parameters, but they are x, y, and z to represent a particular direction and magnitude. Now, if the player moves, I then want to interpolate from my current rotation to the new one that we want to face, which will be where the camera is facing, by using a function called rler, or rotational linear interpolation, which means to move from one place to another within a certain period of time. And I'm going to make that time 0.1. So now I'm going to add in the code real quick to make this work. So again, if we are moving at all, I'm going to change my new rotation, which is to say where we're going to rotate our player next, to the direction that he's currently accelerating in. And we're normalizing it so that it is facing just in that particular direction. And I'm setting the pitch to 0 so that the object isn't looking up at the world or down at the world. We just want to worry about the z-axis. So, and then if we aren't facing there, then we also want to move towards the rotation rather than just set it there. So this is going to slowly move us to that new rotation. And then finally, I call set rotation, which sets my current rotation to what new rotation is. The second function that we'll be writing is called calcCamera, which will calculate where the camera should be. Now what we want that function to do is to orbit the camera around the player using that offset distance variable we created earlier. In addition, we want to make sure that we don't go through walls or the floor, so we're going to make a check for that as well. So going back and finding the calc function, we once again need to call it with the same parameters as what was called before. So I'm going to put that in, and then we can go from there. So here I've added in the definition of our calcCamera function. And I put a little comment at the top here to help people reading the code to understand what each of these parameters are and what they do for us, as well as an explanation of what this function is supposed to do. So again, this function is going to orbit the camera around the player using that offset distance, or in front of walls, whichever one's closer. And so here we have 4 different properties. We have the first one, delta time, which is how much time in seconds have passed between this frame and the last, and the other 3 variables are used to set what the camera's location, rotation, and FOV, our field of view, should be respectively. So, initially, I declare some variables that I'll be using over the course of my function. and then I set a vCam height, a vector called cam height, which will store a vertical line up to my cam height. So I first set my starting position to my current location, and then I set end to the location where we want the camera to be, which we do some simple vector math to get to. But basically, I take the player, move up by my cam height variable in the Z direction, and then move backwards by my camera's offset distance in the player controller's rotation. Then finally, I trace a line from the start to the end to see if there are any objects that intersect. The vect 16, 16, 16 variable is for the extent to trace against. And the idea of that is to think of a box being drawn around the line so that we can tell if it's about to hit the wall rather than just hit the wall. The trace function will return any objects that are there and will set hit location to be where that hit took place. So if trace finds an object, if it's not equal to none, then I will change the camera's location to be where we hit it. So it'll be just before we hit the wall. Finally, I'm going to set the camera's rotation to be slightly above the player facing it. Lastly, I'm going to add in two components that will actually be the visual aspect of the pawn. I'll paste them in and then explain what it is that they're doing. So under default properties, I'm going to add this chunk of code. Now, the first part that we see is a dynamic light environment component. The dynamic light environment component will light our mesh during the game at runtime. Most lighting, by default, is static, which is to say that it doesn't change and is figured out before the game is played. This is much more efficient, and if we can do it, we usually want to. However, our player should look the best as we possibly can do, so we're going to use a dynamic light environment. And I've turned on a property to use a more in-depth lighting algorithm to make it look as better as possible. Finally, we have our good part right here. The skeletal mesh component is the actual visual component of our pawn. Now, if you want to have your own custom character, you'll need to replace the skeletal mesh anim sets, physics assets, and anim tree template, but that's outside of the scope of the tutorial. For more information about creating your own characters, check out the Characters Technical Guide located on the UDN. Finally, so we can see what it is that's currently done with our game, I'm going to save this file, and then I want to go back into our platformer game class. Once we're inside there, I want to comment out the PlayerController class so that we can actually see what this class does and compile our code cleanly. So now, with this done, I'm going to open up Editor once again. It's going to ask us to recompile. And once again, aside from this warning inside of my Hello World trigger, everything else works perfectly fine. So I'm going to go back into the editor once again, and it should start up for us. And once we have this level pop up, I'm going to go to World Properties and then set the game type to instead be Platformer Game for both the default type and the game type for PIE. And then I'm going to hit play in Editor. And so now our game kind of works. We can move the character around. However, our player will always just move without any regards to where it is that the camera's facing. We may want to have our camera function in such a way such that when I look in one direction and then press W, I'll move in that direction and not whatever direction it's facing. We can do that by making use of our own player controller, which is what we'll be doing next. For those of you that would be interested in seeing what a custom asset would look like in the game, Stefan Norn has provided me with a model that you guys can use, which is included in the example code that you guys are given on the project. So, from your example code area, you need to move the female character.upk folder into your content folder of your UDK install. So from the UDK install, UDK game, content. And anywhere inside of here, you need to move this UPK. After that, you'll need to go inside of UDK, and then click on Open on your content browser. Once inside there, select your UPK file and hit Open. And once that's done, you should be able to see the character and all of its assets included here on the project. Now, the next thing that I'll want you to do is to right-click on this skeletal mesh and copy its full name to the clipboard. After that, let's go back into our IDE and go to our pawn. Then the section here, when it sets the skeletal mesh to this skeletal mesh, we're just going to paste the female character in. One last thing that we need to do at the skeletal mesh is double-click on it in order to enter the editor for it. I then need to go into the origin property and modify the origin to be -50 in the z-axis. And that's an issue for just this particular mesh. Now, we'll save and we'll close out. After that, we just need to compile this code. It'll ask us to recompile. And then we'll restart it again. And then once we change the game type once again, we go into play, we now have our custom character instead. So with that, let's get started on the next video. If the pawn is the player's physical representation in the world, the player controller is its brain. It allows us to interface with the pawn and control it in the game. We'll be creating our own player controller to take care of how input will be handled in the game. So again, just like we've previously done, we're going to right-click, go to Add, then New Item. And then we're going to create our class with a name of Platformer Player Controller. And once it's created, we're going to actually declare it. And we want it to extend from Player Controller. Now, we're going to be extending from code that's already been covered in the player. Now we'll be extending from code that was already created inside of the player controller class, overriding some functions to do our own stuff. While we won't be doing any state-based programming, we will need to write code that already exists inside of a state. In our case, the state of player walking, which is whenever the player is standing, walking, running, falling, etc. So we're going to add that in real quick. And inside of the state, we're going to ignore some other functions that are already written. So to ignore functions, we just need to say ignores, and then the name of the functions. When programmers set about programming large and complex systems, they usually tend to create and model their programs into states using something called a state machine. States allow the programmer to focus on the functionality within that state and keep all the related functionality together. Unlike many other languages, UnrealScript has a mechanism for partitioning your code instead of having states built right in. We'll be overriding a function called process move, inside of the state player walking. Now, I'm going to paste this code in for it and then explain what it does. So this is our function, process move. It takes in 4 parameters, just like calc camera, that mean exactly the same as calc camera does as well. I've created 2 variables inside this function which will hold temporary values for us. Temp accel, which is what our acceleration will be, and cam rotation yaw, which we'll be using later. First of all, I want to check to make sure that we have a pawn to work with, because without a pawn, this function would be useless and would have no pawn for us to actually move. This is the kind of error checking that we'll need to use a lot when we're writing scripts. After that, we set where it is that we should be moving. You'll notice here that I'm using the A strafe and the A forward variables of player input, which are if the player wants to move left and right or up and down respectively. You'll multiply that value by delta time. This is very important because as game goes on, the frame rate, which is to say the time taken between frames, can vary. You may have noticed in some games that there'll be a slight slowdown at certain points. What multiplying by delta time does is that it ensures that the player will always move the same amount over time, no matter what's going on inside of the game. Now, if we move just using this acceleration, our player wouldn't move in the direction the camera is facing, which is what we want, so I get the camera's yaw and then rotate my movement by that, and then set the pawn's acceleration to be in that direction. And then I call the face rotation function that we created in our last video. Now, outside of the state, we want to create another function called update rotation that we're going to also be overriding. What this function does is it will tell my pawn what direction it should face. Now this function only has one parameter, which is delta time, which we've already talked about. So let's do another copy-paste and I'll explain what this code does. So again, just like before, I want to make sure that we have a pawn to deal with. If that works correctly, or if it works incorrectly, then I set desired rotation to let the pawn know that I want to face with what my current rotation variable is set to, which we'll actually set later in this function. After that, I'll need to figure out how the player is currently moving the mouse by looking at the values for A turn and A look up respectively. And that'll let me know when the player moves left and right and up and down. Now, after I figure out what that change has happened, I call the function processViewRotation to modify the rotation which I've put into a temporary variable. New rotation to be rotated by the delta rotation and then set to the camera's rotation. I also want the player to face the camera as they move, so I once again call the face rotation function. I also want the player to face the camera as they move, so once again I call the face rotation function. Lastly, I'm going to save this and move right back into my platformer game, and then I'm going to uncomment the PlayerController line, so now it'll be set to our own. And so now, if I go in and I recompile the game for us, we once again create a game with our platformer type, and when we play the game, Now, if I move the camera and then press W, we walk towards where our camera is pointing to, which is exactly what we want. Now, there are some additional things that we may want to add additional polish to our game, so that's what we're going to be doing in the next video. Now at this point we have a working prototype, and that's great. But now let's add one more additional feature to make the camera really pop. The ability to zoom in and out at will within a particular range that we can set. When playing our game, the camera works fine, but what if our player wanted to get a larger view of the area? Or maybe they wanted to admire that nice camera model that we made, our character model that we made. We can fix that by adding in the ability to zoom in and out with our camera, which is what we're going to be doing now. Inside of our Platformer Pawn class, we're going to create two new functions called Cam Zoom Out and Cam Zoom In, which will zoom the camera in and out respectively, or out and in respectively. After that, we'll call those functions from our PlayerController when the player moves his mouse wheel up or down. So inside the Platformer Pawn files, we're going to declare some additional variables for us to use. So I'm going to create the variables of how close and how far we want the camera to be. And I'm going to name them Cam Min Distance, and the max distance I'm going to name Cam Max Distance, and then a semicolon at the end. Next, we're going to want to add how fast we want the zoom to occur. And that's going to be far float cam zoom speed. Now, inside the default properties, we'll need to initialize these new values. So inside here, I'm going to put and then cam zoom speed, I'm going to set equal to 2000. We want it to be pretty fast. Now, above the default properties, we need to create those functions, our cam zoom in and our cam zoom out. So here, now, I'm going to put in some comments to explain what this function is doing. This is a good habit for us to get into. So to do that, I'm going to put in after this, I'm going to check if the camera's offset from the player isn't too close. So if cam offset distance is greater than cam min distance, then finally we're going to move the camera back. So we're going to set it to cam offset distance minus equals world info dot delta seconds times cam zoom speed. So I'm using the time that we've taken times our cam zoom speed. And what minus equals does is it takes the current value that cam offset distance has and it subtracts from it this value. So now I'm going to copy and paste this function and change the name to zoom out instead of zoom in. And then from there, I just need to change the minus equals to plus equals and the distance to max distance and less than. Now we actually need to call these functions. As we need to have input from the player to actually have our mouse wheel work, we need to make use of the PlayerController. So let's go over to that class. So inside the PlayerController class, there are actually two functions that are already written that are called whenever the mouse wheel moves up or down. And those functions are called nextWeapon and prefweapon. So since this is a simple example, I'm just going to overwrite them. So first, we need to declare our functions. So here I'm going to put exec function nextWeapon and exec function prefweapon. Now, what exec means is basically if we type the name of the function inside of a console command, this function would actually get called. Now, I know that we're using the platformer game right now, but for the sake of argument and to make sure our code is written nicely and that it won't crash, let's make sure that the pawn that this player controller is using exists and that it is indeed a platformer pawn. I can do that by writing the following. If platformer pawn is not equal to none. If pawn is not a platformer pawn, this will return null. So if this returns true, we know that we have a platformer pawn, so now we can use anything that the platformer pawn class has. So in this instance, I can call my camera zoom out function. So here I can put platformer pawn dot and then cam zoom out. Now I just need to copy paste this and put in cam zoom in instead. Now let's compile the game and try it out. And now we can load up our persistent level, change the world properties so that both game types are platformer game, and we jump in. You'll see that we can now use the camera or the mouse wheel to zoom in and out for our project. And now we have a fully working and fully functional camera, which lets us know exactly where our character is. Now that we basically have our project completed, in the next section, we'll do some very final polish stuff to get our project all the way ready for completion. Welcome to UDK Game Development. My name's John P. Doran, and this is Section 7, Completing the Project. In this section, we're going to be taking a look at how to create a custom loading screen, how to create a custom main menu, how to replace the escape menu, how to replace our splash screens, and finally, how to create an installer for your game. So with that, let's get started. Now that our game is finally complete, we're now going to take the steps needed to make our game feel like a complete product instead of just a UDK mod. The first step we're going to take to do this is to replace the default loading screens. Now, if we try to load the game by either going through the Start menu or through our UDK install folder, binaries win32, and then double click on the udk.executable.exe file, we'll get to see what the game does by default when we load it. Now, if we attempt to open up any level, you'll see that when it was loading, that it was actually showing me a bunch of the Unreal Tournament characters. Now, our game is an Unreal Tournament game, so we're going to replace all these assets that we saw. So the first thing that we're going to do is we're going to replace this menu with one of our own. So to close the game, I'm going to hit Alt-Tab, and then right-click on my UDK game and select Close Window. Okay, so I've created a JPEG file ahead of time, which you can find inside of your code file. Now, this is what we're going to be using in order to replace our default loading screen. Now, the default load screen is of a type called a BINC video. Now, BINC is a video codec in the same way that DivX and AVI are, and that's what UDK uses to load videos. Now, to actually turn this JPEG into a .bic video, we'll need to download the Rad Video Tools program, which you can find for free at radgametools.com/bnkdown.htm. Now, in order to do it, we're going to click on the download, save it, and then once it finishes, double-click to start it up, and then hit run. We'll hit next, install, and then once you go through the installer, we'll now start up the program. So you can just go to Start, Programs, BINC and Smacker, and then the Rad Video Tools. Now once here, you'll be asked for the file that you wish to convert. So I'm going to go to that folder, and then I'm going to select my JPEG. And once here, we're going to select the BINCit logo. We want to type the BINCit button on the bottom left. Once there, you'll be asked for the output file info name. Now, this is very important because you'll need to remember it for later. Once you finish, click on the BINC button on the right and wait for it to finish. Now, I already have one, so I'm going to say to overwrite it, but you shouldn't see that. Once done, we can now close out of the program. So hit done and close on out. And then you should have this BIC file. Now, for the sake of this tutorial, I'm just using a JPEG file for the basis of my loading screen, but you can also provide a .avi file of your own as well to convert to that BIK. Now, with your BIC file selected, I want you to go to your UDK install folder, and then inside the UDK game movies folder, you'll see that we need to put some movies there. The loading screen is actually chosen from random. Now we need to move over our video over to the UDK game/movies folder. And there we go. Now, the loading screen is actually chosen from random from the load map movies array specified in the full screen movie section of our default engine.ini file. So let's go to that file right now. So back inside our UnrealScript IDE, we'll open it up real quick. So once it loads up, we're going to go back into our UDK game config project, and we're going to open up the default engine.ini file. Now once we're here, I'm going to use Control F, and then I'm going to look for full screen movie. And there we go. So now I'm going to replace load map movies with load screen. Or if you want to keep what it said previously, I can put a semicolon at the beginning of this line, and this actually comments out what was written before. So now I can just add to the end of this file, load screen. Now, if we want the text to show up, we're now done. However, if we don't want to see the text at all, we can fix that now by diving into some code. Now, the text is drawn in a class that's called UT Game Viewport Client in a function called draw transition. Now, we could just go into our file and comment out that function, but it's a good idea to never modify Epic's code at all because it's typically used as the base game. So if we change it here, we modify what UDK does by default. In general, think of Epic's code as a common library from which we can extend from or modify. So with that in mind, we're going to do this in a longer but safer way. So to do that, I'm going to create a new class, just like before, and I'm going to call it Platformer Viewport Client. So here, create a new file, go to Platformer Viewport Client. And I'm going to make it extend from the class UT Game Viewport Client. And then I'm going to create the function draw transition, and this function takes a canvas property called canvas. And that's all we need to do. So after we write this, I can delete the default properties because I'm not putting anything in there. Accidentally hit the toolbox button, so we'll close that. So I can delete the default properties section and save this file. Now we're going to have to go back into the default engine.ini file. Next, I'm going to have to modify a property called Game Viewport Client class name, and I need to change it to MyScripts.Platformer Viewport Client. And again, if I want to keep whatever was there beforehand, I can just copy what I changed, paste the new one, and comment out the old one. Finally, I need to add one last thing, which is located inside of the engine.script packages section. And I need to add as a non-native game package MyScripts. This will make sure that our files in the MyScripts package are available as soon as the game starts. This is important as the game will not compile without this being set, now that we're using the Platformer Viewport Client. With that being done, now we just need to compile our game and run it. Now, if we want to fix this hello world trigger warning, we can just add simulated to the beginning of post begin play. So if I go to my hello world trigger once again, and I change this function to be function simulated, and compile our code once again, it should work completely fine for us. And there we go. We're perfectly fine now. So we can close this out and start the game. One thing to note is that whenever you're using UDK or wanting to recompile your scripts, you have to make sure that the game is not loaded. So we'll start the game once again. And with that, we'll open up our level. And there we are. And with that, we now have a loading screen that just lets us know that it's loading. For the purposes of our level, it shouldn't be up for more than a short period of time, but it actually goes a long way towards adding that polish for our actual title. Along with that same line of thinking, in the next section, we'll be doing that as well by creating a main menu to replace the one that we just saw. A fundamental part of a complete game experience is a main menu to welcome people to the game and allow them to exit, which is what we'll be doing now. If we start up the game at this point, you'll notice that what we see is this built-in UDK menu. Now, this menu has nothing to do with the project that we've created. We could create a complex system of user interfaces using Scaleform or Canvas, but for our purposes, we can just create a simple main menu using a few Kismet actions to help people get in and exit our game. So with that, we'll do that now. So to start our level, we're going to open up the UDK editor. So our menu is going to be very simple. It's not going to need a backdrop of any kind. So in order to do that, we need to create a level that's completely empty. So I'm going to go to File, New Level, and then select Blank Map. After we have this, I'm going to create a hollow room with no lights by right-clicking on my Brush Builder button and creating a 512 by 512 by 512 box that's hollow. Once I hit Build, we should be able to create something. And if you want to see what the box will look like, we can hit B to show our builder brush again. So with this being placed, I'm going to hit the Add button, and we'll see this box show up. So I can close out of the brush builder, and you'll see that this is here. Now you'll notice that at the top here, the lighting is currently set to unlit. If I change this to lit, you'll see it's completely black. So after this, I need to create a player start in the middle of the room by right-clicking and selecting Add Actor, Player Start, and there we go. And then after this, I just need to go to Build, and then Build All. And with that, our player now has a black room that they won't notice exists. Next, we'll need to import an image file for our main menu. To do so, we'll go into the content browser, and then we want to load in an image file for our main menu. So I'm going to click Import, and then going into my folder, I'll select my main menu.png file, and then hit Open. I'm going to add it to a package, platformer assets, and its name is fine as main menu. Then we'll hit OK. And then I'll need to right-click and save this action. Then hit Save. Once this is done, we'll need to go into Kismet. So we'll open up the Kismet window, and we'll create a Draw Image event by right-clicking and selecting New Event, HUD, Draw Image. Now for the texture to draw, go to the HUD part of the section, and under Display Texture, we'll need to go to the Content Browser, select our main menu texture, main menu, select it, and then click this green arrow right here. Now, some of these properties that you see here may be a bit confusing. XL is the relative width of our object, so I'm going to put 0.5. YL is the relative height. U is the start from the left of the image. V is the start from the top of the image. UL is the size of the texture, which is 512, and here is 512 as L. So it's a 512 by 512 texture. Then we'll need to actually place it in the world. So under the X property of the display location, I'm going to put in 0.25, and I'm going to make the Y a 0.1. You'll need to play around with these values to find the ones that you like in the image. Finally, we'll set the isActive to true. Now we have the visual set, but now we need to make it so that whenever we press Enter, we start the game, and when we press Escape, it'll work for us to quit. So to do this, we're going to create a key pressed event by right-clicking and selecting New Event, Input, and then Key Button Pressed. To the right of this, we're going to create a console command by going to right-click, New Action, MISC, Console Command, and then connect the pressed to the in of my console command and create a player variable for my target. After this, we're going to copy paste this entire action because we're going to have two events for keys being pressed. And there we go. It's Control C to copy, Control V to paste. In the first one, I'm going to change the sequence event input names. I'm going to press plus, and for the first one, I'm going to type in the word enter. And then I'm going to have the console command be open, and then the name of your level, that's your persistent level. Next, we'll change the input name to escape, and we'll make the console command quit. Finally, I'm going to add a comment to each of these when they're called by selecting the event, go to the sequence object section, and under object comment, here I'm going to put quit game, and check mark output object comment to screen, and uncheck suppress auto comment, and then I'm going to do the same here to open map in the same action. We'll have to set the target for the draw image to our player as well. So we'll create a new player variable and connect that to target. We will also need to change the display color from this black to this white image right here. Finally, if we go and play the game, you'll see our menu show up. And if we press the enter key, you'll see it say to open the map, and if I hit escape, you'll see it quit. Now we'll override one last thing to make our game finally complete. Pressing escape to go to the main menu screen while playing the game. Now, if we go to play it on PC, you'll see that our main menu screen now shows up. You'll see I can hit enter to start our game. However, if we press escape, nothing happens. Instead, we want to go straight back to our main menu screen. So to do that, let's first exit by Alt-tabbing, right-clicking, and closing, and then going back into our editor. So next, we're going to now go into a new INI file called defaultinput.ini. Once in there, we want to find the input for what happens when we press the escape key. Now, if you find it the first time, you'll see that we'll go to Control F and we'll type in escape. And there we go. Now the first time you'll see here that it's actually removing bindings, so that's not the one that we're looking for. So the next thing we're going to do is find the next one, and you'll see that this now calls GBA show menu whenever we press the escape key. Let's copy and paste these lines so we have two different copies. I'll comment out this one, and in this one I'm going to put in open main menu, just like the console command. So this will call the console command open main menu when our event starts. So next we'll need to save our level. I'm going to save. Level, and I'm going to name the level main menu, just like I said in the INI file. And now we're going to close the game and restart it for the INI file to show up. So now I'm going to open up the game. And then I'm going to hit the backtick key in order to bring up the console command window. This is the key that's to the left of the 1 on US keyboards. Once we have that up, type in open main menu, and this should open up the game for us. So now when I press enter, I go into the game, and then when I press in escape, we go back to the main menu. Perfect. Finally, you'll notice that when we start the game, our player falls through the world. And that's because the level's still loading the first level when we start to fall through. So in order to fix that, I'm going to quit the game and then dive right back into the editor. And then I'll open up our persistent level, and then where our player spawns, I will move the floor to the persistent level. So in here, I'll go to levels, we'll select the persistent level, make sure that we're in the persistent level rather, then select this object, right click, select level, and then move selected actors to the current level. After that, we can build all, and then we need to make sure to save the level. Now with all that done, we'll save all our packages and then start the game. And now if we open the map, you'll see that it shows up fine. So with that, let's move to the next video. One of the final things I'll show you how to replace is the artwork for UDK splash screens. These splash screens are what you see whenever you start UDK through the editor or on the PC. You also may have multiple versions of UDK installed on your computer. Replacing these assets make it a lot easier to make sure that the version of UDK you're using is the correct one. It's actually quite easy to do this, and that'll be what we're doing now. So let's go in from our UDK install folder into UDK game, splash, and then PC. You'll notice there are two bitmap files here. You can just very simply replace these with ones of your own. So here I'm dragging Ed Splash, and I'm replacing, and I'm going Splash, and then replacing. And these are located within the code assets that we've provided on PAC's website. Now, you can replace these with your own files as well, as long as they're the correct size. And there we go. If we start the game, you'll see that it's now using our splash screen. And if we start the game from the editor, it'll also show our splash screen. One thing to note, please do make sure that you have permission to actually replace these assets. If you look at the UDK facts page, it says that these new materials need to be approved in PDF format by an email to Epic's marketing department. To see the specific page, please visit the UDN Development Kit facts page right here. At this point, you have all the beginnings of an amazing game. Once you're finished with your version of the game, you want to make it easy for people to download and to play it. That's what packaging and cooking are for. Cooking makes the content consumer ready by compressing textures and doing a ton of different things to make the game ready to be installed on different systems, similar to a final compile on a normal project. Cooking will also combine all of your content packages into just a few files, a process that will also protect your content from hacking. It'll be much harder to extract things out of a cooked and a combined package. To kick off this process, let's open up the Unreal Frontend.exe program, which is located inside of the binaries folder of our UDK install, which is right here. Once you double-click on the icon, we open this up. Once the front end is loaded, you'll notice that there's a section called Maps to Cook. Clear out this list, and then add in all of your other levels here. So we'll click Add, and we'll need to add the main menu. we'll need to add in our persistent level, and then we'll need to add in our other levels that we load in, so our game world and game world 2. One thing to note is that the cooking process, or the front end, does not like level names with spaces in them. After this, at the launch map section, we want to check override default. So we will load our own map, and the map we want to load by default is the main menu. Next, we're going to want to enable package game if it's not enabled already. It will look like this by default. So to enable it, we'll select package game and step enabled. If you want the game to launch whenever it finishes, this step needs to be enabled as well. So after this, we'll click the Start button and we'll wait for it to finish. And there we go, the game is started. Once you get to the package game section, it'll ask you some questions on what your game's name is and a shorter name for it to go by. So I'm going to type in platformer game, and its shorter name is platformer. Then after that, we'll hit package game. Now that it's all finished, we can go to our UDK folder, and you'll see this executable file. The content of this will be our installation. So if we double click this, this is an installer that will have us install our finished package game ready for our players to play. And there we are. It's taken a bit of time, but we've made it. Our game is now complete, and we have a packaged version that we can distribute to people easy. Welcome to UDK Game Development. My name's John P. Doran, and this is Section 8, Where to Go From Here. In this section, we're going to take a look at the Unreal community and the Unreal Developers Network, or UDN. With that being said, let's get started. Welcome to Section 8. At this point, you have a completed game. So in this section, we're going to take some time to guide you on some resources that may be able to help you work better within UDK. Now, we could spend all the time in the world working on our project. We could try to get it to that perfect state, and we'll always keep wanting to add new features and solve bugs for a project. However, at some point, you're going to run into some issues, whether it be with code or how you work with the engine, or maybe you just want to know how to do something. That's where talking to fellow developers come into place. The Epic Games Community Forum, located at forums.epicgames.com, is a great place to look for information when working with UDK. They actually have an entire section here that has to do solely with UDK development, and have a number of different subforums having to do with different aspects of creating, such as level design and creation and UDK programming. They also have an incredibly large backlog, over 1,000 pages having to do with programming questions that have already been asked in the past. For 99% of the time, the problem that you have has already been asked before and has already been solved. So do take some time to check out the search bar in the top right-hand corner to check before creating a new thread. You can also usually find multiple solutions for the same problem. Or perhaps, when seeing how someone else solved the problem, you can come up with your own solution. It may be a good idea to share it with the community, though. One thing to note is that sometimes you may need to search multiple times for what it is that you're looking for. For example, instead of typing in the word enemy, you could search for bots, which is the UDK term for it. Also, a lot of times, if you include UDK in a search form inside of Google, you'll notice that the Unreal Forms is typically near the top of the results as well. However, there may come a time when you actually want to get in and learn generic stuff about the engine and/or may need general help. For that, we'll take a look at the Unreal Developers Network, or UDN, which is what we're going to be talking about next. The Unreal Developers Network, or UDN for short, is a resource that's used by both AAA game developers and modders as a support site, containing an overview of everything having to do with Unreal. Now, we may have come to a point in your work where you may need to add something, but you're unsure of where to start and need some kind of manual or support to lead you on the right path. Or perhaps you want to know what options there are that already exist inside of Unreal. For both of those conundrums, the UDN is the perfect spot for you. In the Inside Unreal Engine 3 section, which I have right here, you'll see that there's all sorts of content having to do with working with Unreal. Note that these sections are usually just documentation explaining how things work. But there are also pieces of example code and gems that you can also use to make your life easier. In addition to all the content on the UDN page, there's also a section called the Community Links section, which contains a huge amount of tutorials and documentation about working with UDK as well. This is actually how I learned UDK, and there are actually some really good things in here. But note that UDK is an engine that changes over time, and stuff that may have worked previously in these tutorials may not work anymore. Going along the same line of thought, there are also a couple of other websites that I've found some really great tutorials that aren't listed on here. Now, for those of you that want to make their levels look prettier, World of Level Design is another community that has a section on creating things with UDK, and it has some really nice content. In addition, for those of you that are interested in doing more project work at a slower pace, for a series of more complex projects using Kismet or about using Scaleform to do much more complex user interfaces, you can take a look at Getting Started with UDK or Mastering UDK Game Development, available from Pack Publishing, and both of which were written by me. If you'd like to learn more about using UnrealScript, I'm a really big fan of Rachel Cordone's Unreal Development Kit Game Programming with UnrealScript Beginner's Guide. Now, for those of you that are interested in porting your game over to iOS, you can use the UDN as a resource, but I've also written another book on that subject as well, or co-wrote the book, which is also available through Pact. With that being said, it's been an absolute pleasure to work with you on this, and I hope that it was just as pleasurable for you. Over the course of this video series, we've created a game from a blank level in UDK, and we've created a new game from scratch, leveraging some of the many tools that Unreal has for you, while also diving into writing our own UnrealScript when needed as well. You're now armed with the basic knowledge of how to create a custom game using the Unreal Engine. What you do next is entirely up to you. Good luck, and game on!